Welcome to our exploration of whether God plays a role in modern astrophysics. Let's begin by defining astrophysics. As a branch of astronomy, astrophysics seeks to understand the physical properties and behaviors of celestial bodies and the universe as a whole. It delves into the fundamental principles governing the cosmos, such as gravity, electromagnetism, and nuclear interactions. Astrophysicists utilize mathematical models, observational data, and theoretical frameworks to unravel the mysteries of the cosmos. Through astrophysics, we aim to comprehend the origins, evolution, and ultimate fate of the universe. Astrophysics encompasses a vast array of topics, ranging from the study of stars and galaxies to the exploration of cosmic phenomena like black holes and dark matter. By probing the depths of space and time, astrophysicists seek to uncover the underlying laws governing the cosmos. Through observations made using telescopes, satellites, and other instruments, we gather data to test hypotheses and refine our understanding of the universe's workings. The field of astrophysics is inherently interdisciplinary, drawing upon principles from physics, mathematics, chemistry, and other scientific disciplines. By integrating diverse areas of knowledge, astrophysicists strive to develop comprehensive theories that explain the observed phenomena in the universe. From the smallest subatomic particles to the largest cosmic structures, astrophysics offers insights into the intricate tapestry of the cosmos. Astrophysics also plays a crucial role in advancing our technological capabilities. Many of the technologies we use in everyday life, such as GPS systems and medical imaging devices, have their roots in astrophysical research. By pushing the boundaries of scientific inquiry, astrophysicists drive innovation and inspire technological advancements that benefit society as a whole. At its core, astrophysics is driven by a spirit of curiosity and exploration. By asking fundamental questions about the nature of the universe, astrophysicists seek to unravel its mysteries and expand the boundaries of human knowledge. Through observation, experimentation, and theoretical analysis, we strive to unlock the secrets of the cosmos and gain a deeper understanding of our place within it. Join us as we embark on a journey through the cosmos, exploring the intersection of science, religion, and philosophy in the quest for cosmic understanding. Throughout history, the relationship between science and religion has been complex and multifaceted. While there have been periods of conflict and tension, there have also been instances of cooperation and mutual enrichment. From ancient civilizations to the modern era, humanity has grappled with questions about the nature of the universe and our place within it. Both science and religion offer distinct perspectives on these fundamental questions, each with its own methods of inquiry and modes of understanding. In ancient civilizations, religion played a central role in explaining natural phenomena and organizing society. Myths, rituals, and religious texts provided explanations for the workings of the natural world, often invoking divine beings or supernatural forces. Early astronomers and philosophers observed the movements of the stars and planets, seeking to understand their significance within the cosmic order. While these early cosmologies were often intertwined with religious beliefs, they laid the groundwork for the development of scientific inquiry. During the Middle Ages, the Catholic Church emerged as a powerful institution that wielded considerable influence over intellectual and cultural life in Europe. Religious authorities supported scientific inquiry, believing that the study of the natural world revealed the wonders of God's creation. Many early scientists, such as Copernicus, Galileo, and Kepler, were devout believers who saw their work as a means of uncovering the divine order of the universe. However, tensions arose when scientific discoveries challenged prevailing religious dogma, leading to conflicts such as the Galileo affair. The Enlightenment marked a period of profound intellectual and cultural transformation, characterized by a shift towards secularism and rationalism. Enlightenment thinkers championed the principles of reason, empiricism, and skepticism, advocating for the separation of church and state. Scientific advancements, such as Newton's laws of motion and universal gravitation, fueled optimism about humanity's capacity to understand and control the natural world. However, this period also witnessed the rise of atheism and skepticism, as some intellectuals questioned the validity of religious beliefs in light of scientific progress. In the modern era, science and religion continue to coexist in dynamic and sometimes contentious ways. While scientific discoveries have revolutionized our understanding of the universe, religious beliefs persist as deeply held convictions for billions of people around the world. Many religious traditions have adapted to accommodate scientific insights, interpreting sacred texts in light of modern knowledge. At the same time, conflicts persist over issues such as evolution, cosmology, and the origins of the universe. Despite these challenges, many scientists and religious believers see potential for dialogue and collaboration. The field of science and religion seeks to bridge the gap between these two domains, exploring the ways in which they can inform and enrich one another. Scholars from diverse disciplines engage in interdisciplinary research, examining the intersections between scientific and religious worldviews. Through dialogue and mutual respect, we can cultivate a deeper appreciation for the complexities of the human experience and the mysteries of the cosmos. Understanding the role of God in modern astrophysics is of paramount importance. It offers insights into the deeper meaning and purpose behind the scientific exploration of the cosmos. By grappling with questions about the existence and nature of God, astrophysicists can cultivate a more holistic understanding of the universe. This interdisciplinary approach allows for a richer dialogue between science, religion, and philosophy, fostering greater appreciation for the complexities of existence. Exploring the role of God in modern astrophysics also addresses fundamental questions about the origins and ultimate fate of the universe. By considering theological perspectives alongside scientific evidence, we can gain a more nuanced understanding of cosmic phenomena. This integrative approach encourages humility and openness to diverse viewpoints, recognizing the limitations of human knowledge in the face of cosmic mysteries. Moreover, understanding the role of God in modern astrophysics has profound implications for human values and ethics. By reflecting on the divine attributes attributed to the cosmos, such as order, beauty, and purpose, we can cultivate a sense of awe and reverence for the natural world. This spiritual dimension enriches our appreciation for the wonders of the universe and inspires us to act as responsible stewards of creation. Furthermore, exploring the role of God in modern astrophysics fosters a sense of interconnectedness and unity among diverse religious and cultural traditions. By recognizing the common human quest for meaning and transcendence, we can bridge divides and foster greater understanding and cooperation. This inclusive approach promotes dialogue and mutual respect, fostering a sense of solidarity in our shared exploration of the cosmos. In addition, understanding the role of God in modern astrophysics can provide comfort and solace in the face of existential uncertainties. By contemplating the divine presence within the vast expanse of the universe, we can find reassurance in the belief that we are part of something greater than ourselves. This spiritual perspective offers hope and resilience in times of adversity, guiding us through the complexities of life. Furthermore, exploring the role of God in modern astrophysics invites us to consider the relationship between science and faith in our personal and professional lives. By integrating scientific inquiry with religious reflection, we can cultivate a more holistic approach to understanding the universe. This integrative perspective encourages intellectual curiosity and spiritual growth, enriching our lives and deepening our appreciation for the mysteries of existence. Moreover, understanding the role of God in modern astrophysics encourages humility and awe in the face of the vastness and complexity of the cosmos. By acknowledging the limits of human understanding, we can approach scientific inquiry with a sense of wonder and reverence. This humble stance fosters a spirit of openness and curiosity, driving us to explore the unknown and expand the boundaries of knowledge. Furthermore, exploring the role of God in modern astrophysics challenges us to confront our assumptions and biases about the nature of reality. By engaging with diverse perspectives and worldviews, we can broaden our horizons and enrich our understanding of the universe. This inclusive approach fosters empathy and compassion, cultivating a deeper appreciation for the diversity of human experience. In addition, understanding the role of God in modern astrophysics invites us to reflect on the ethical and moral implications of our scientific pursuits. By considering the ethical dimensions of our research and technological advancements, we can ensure that our actions are guided by values of justice, compassion, and respect for life. This ethical framework encourages responsible stewardship of the cosmos and promotes the well-being of future generations. Moreover, exploring the role of God in modern astrophysics deepens our appreciation for the interconnectedness of all life on Earth and beyond. By recognizing the sacredness of the natural world, we can cultivate a sense of reverence for the web of life that sustains us. This ecological perspective inspires us to act as caretakers of the planet, nurturing biodiversity and preserving the beauty and diversity of life. Furthermore, understanding the role of God in modern astrophysics fosters a sense of wonder and awe in the face of the mysteries of the cosmos. By contemplating the vastness and complexity of the universe, we can cultivate a sense of humility and gratitude for the gift of existence. This spiritual perspective enriches our lives and deepens our appreciation for the beauty and wonder of the cosmos. In addition, exploring the role of God in modern astrophysics invites us to consider the ultimate purpose and meaning of our lives. By reflecting on the cosmic significance of human existence, we can find meaning and fulfillment in our quest for knowledge and understanding. This existential perspective encourages us to live with purpose and intention, striving to make a positive impact on the world around us. Moreover, understanding the role of God in modern astrophysics can inspire us to approach scientific inquiry with a sense of reverence and wonder. By recognizing the divine presence within the natural world, we can cultivate a deeper appreciation for the mysteries of the cosmos. This spiritual perspective enriches our scientific endeavors and fosters a greater sense of connection to the universe as a whole. Furthermore, exploring the role of God in modern astrophysics challenges us to confront our assumptions and preconceptions about the nature of reality. By engaging with diverse perspectives and worldviews, we can expand our understanding of the universe and our place within it. This inclusive approach fosters intellectual humility and promotes greater empathy and understanding among people of different faiths and cultures. Early astronomical observations were often intertwined with religious interpretations, as ancient civilizations sought to understand the movements of celestial bodies and their significance. In Mesopotamia, Egypt, and other ancient cultures, the stars and planets were regarded as divine beings or symbols of gods and goddesses. Religious rituals and ceremonies were often tied to astronomical events such as solstices, equinoxes, and eclipses, reflecting the belief that the heavens exerted influence over earthly affairs. Ancient astronomers meticulously observed the motions of the stars and planets, charting their positions and predicting celestial events with remarkable accuracy. These observations were recorded in texts such as the Babylonian astronomical diaries and the Egyptian Book of the Dead, which served as repositories of astronomical knowledge and religious wisdom. By studying the heavens, ancient civilizations sought to discern the will of the gods and divine the course of destiny. In ancient Greece, philosophers such as Pythagoras and Plato laid the foundations for a more systematic approach to astronomy, seeking to understand the underlying principles governing the cosmos. The concept of a geocentric universe, with Earth at the center and the celestial spheres revolving around it, emerged as a dominant cosmological model. This worldview was deeply influenced by religious beliefs about the divine order of the cosmos and the harmony of the spheres. In ancient India, astronomy was closely linked to religious practices such as astrology and Vedic rituals. The Rig Veda, one of the oldest Hindu scriptures, contains hymns dedicated to the sun, moon, and stars, celebrating their divine attributes and cosmic significance. Indian astronomers developed sophisticated mathematical techniques for calculating planetary positions and predicting celestial phenomena, laying the groundwork for the later development of astronomy in the region. In ancient China, astronomy played a central role in the practice of divination and the governance of the empire. The Chinese believed that the movements of the celestial bodies reflected the will of the gods and could be used to forecast auspicious or inauspicious events. Astronomical observations were recorded in texts such as the Book of Changes and the Book of Documents, which served as guides for interpreting celestial omens and governing the affairs of state. Throughout the ancient world, religious beliefs shaped the way people understood and interpreted astronomical phenomena. The stars, planets, and constellations were seen as manifestations of divine power and celestial order, reflecting the overarching principles of creation and cosmic harmony. By studying the heavens, ancient astronomers sought to unlock the mysteries of the universe and gain insight into the workings of the divine. As we reflect on the early history of astronomy, it is important to recognize the profound influence of religious beliefs on the development of astronomical knowledge. The interplay between science and religion in ancient civilizations laid the groundwork for the emergence of modern astrophysics, shaping the way we understand the universe and our place within it. By exploring the rich tapestry of human thought and experience, we can gain a deeper appreciation for the complex relationship between science, religion, and philosophy. Religious scholars made significant contributions to the field of astronomy throughout history, blending spiritual insights with scientific inquiry. In ancient civilizations, priests and sages served as custodians of astronomical knowledge, using observations of the heavens to determine religious festivals, agricultural cycles, and celestial omens. These early astronomers developed sophisticated methods for tracking the movements of the stars and planets, laying the groundwork for the later development of astronomy as a scientific discipline. In medieval Europe, religious institutions such as monasteries played a central role in preserving and transmitting astronomical knowledge. Monks and clerics studied the works of ancient astronomers such as Ptolemy and Aristotle, translating Greek and Arabic texts into Latin and expanding their understanding of the cosmos. Monastic observatories were established to study celestial phenomena and compile astronomical tables, which were used for calendrical purposes and navigation. Islamic scholars made significant advances in astronomy during the Golden Age of Islam, drawing upon Greek, Indian, and Persian sources to develop new theories and techniques. Muslim astronomers such as al-Battani, al-Khwarizmi, and Ibn al-Shatir made groundbreaking discoveries in areas such as celestial mechanics, trigonometry, and observational astronomy. Their contributions laid the foundation for the later development of modern astronomy in Europe and beyond. In ancient China, Confucian scholars and Taoist priests were instrumental in the development of Chinese astronomy, which was closely linked to religious practices such as divination and astrology. Chinese astronomers meticulously observed the movements of the sun, moon, and stars, developing sophisticated methods for predicting eclipses and calculating the positions of celestial bodies. Their astronomical observations were recorded in texts such as the Book of Changes and the Book of Documents, which served as guides for interpreting celestial omens and governing the affairs of state. In ancient India, Brahmin priests and Hindu scholars made significant contributions to astronomy, which was regarded as a sacred science closely tied to religious rituals and cosmological beliefs. Indian astronomers developed mathematical techniques for calculating planetary positions and predicting celestial phenomena, laying the groundwork for the later development of astronomy in the region. The astronomical knowledge preserved in Hindu scriptures, such as the Vedas and the Puranas, continues to inform religious practices and cultural traditions to this day. Throughout history, religious scholars have played a vital role in advancing our understanding of the cosmos and its mysteries. By blending spiritual insights with scientific inquiry, they have enriched our appreciation for the beauty and complexity of the universe. Their contributions to astronomy serve as a testament to the power of human curiosity and the enduring quest for knowledge and understanding. As we reflect on the contributions of religious scholars to astronomy, it is important to recognize the diverse cultural and religious traditions that have shaped our understanding of the cosmos. By studying the works of ancient astronomers from different civilizations, we can gain a deeper appreciation for the rich tapestry of human thought and experience. Their insights into the workings of the universe continue to inspire and inform scientific inquiry to this day. Moreover, the interdisciplinary approach of religious scholars to astronomy highlights the interconnectedness of science, religion, and philosophy. By integrating spiritual and scientific perspectives, they sought to unlock the mysteries of the cosmos and uncover the underlying order of the universe. Their holistic approach to understanding the natural world serves as a model for contemporary efforts to bridge the gap between science and spirituality. Furthermore, the contributions of religious scholars to astronomy underscore the importance of cultural exchange and cross-cultural dialogue in the pursuit of knowledge. Through interactions with scholars from different religious and cultural backgrounds, ancient astronomers exchanged ideas, shared observations, and collaborated on research projects. These exchanges enriched their understanding of the cosmos and fostered a spirit of cooperation and mutual respect. In addition, the legacy of religious scholars in astronomy reminds us of the enduring quest for meaning and understanding that transcends cultural and religious boundaries. By seeking to unravel the mysteries of the universe, they grappled with questions about the nature of existence, the origins of life, and the ultimate fate of the cosmos. Their insights into the cosmic order continue to inspire and challenge us, to explore the unknown and expand the boundaries of human knowledge. Moreover, the contributions of religious scholars to astronomy highlight the importance of humility and reverence in the face of the vastness and complexity of the cosmos. By acknowledging the limitations of human understanding, they approach the study of the heavens with a sense of awe and wonder. Their spiritual insights into the mysteries of the universe continue to inspire us to contemplate our place within the cosmic tapestry and to strive for a deeper understanding of the divine order that pervades all of creation. Furthermore, the interdisciplinary approach of religious scholars to astronomy serves as a reminder of the interconnectedness of all knowledge and the importance of integrating diverse perspectives in the pursuit of truth. By drawing upon insights from science, religion, and philosophy, they sought to create a holistic understanding of the cosmos that transcended disciplinary boundaries. Their efforts to synthesize spiritual and scientific knowledge continue to inspire us to seek greater unity and harmony in our exploration of the universe. Lastly, the contributions of religious scholars to astronomy demonstrate the enduring power of human curiosity and the quest for meaning in the face of the unknown. By gazing up at the stars and pondering the mysteries of the cosmos, they sought to unlock the secrets of existence and to glimpse the divine order that governs the universe. Their legacy reminds us of the importance of nurturing our sense of wonder and awe as we continue to explore the wonders of the cosmos and unravel its mysteries. During the Enlightenment era, a period of intellectual upheaval and cultural transformation, tensions between science and religion came to the forefront. Enlightenment thinkers championed reason, empiricism, and skepticism as the foundations of knowledge, advocating for the primacy of scientific inquiry over religious authority. The rise of secularism and rationalism challenged traditional religious beliefs and institutions, leading to conflicts over issues such as the nature of the universe, the origins of life, and the role of human reason in understanding the world. Scientific discoveries during the Enlightenment, such as Newton's laws of motion and universal gravitation, fueled optimism about humanity's capacity to understand and control the natural world. These advancements undermined traditional religious cosmologies and challenged the authority of religious leaders to interpret the natural order. The conflict between science and religion intensified as intellectuals questioned the validity of religious beliefs in light of empirical evidence and rational inquiry. The publication of works such as Galileo's dialogue concerning the two chief world systems and Darwin's On the Origin of Species sparked fierce debates about the relationship between science and religion. Galileo's advocacy of heliocentrism and Darwin's theory of evolution challenged religious doctrines about the origins of the universe and the diversity of life on Earth. Religious authorities condemned these ideas as heretical and sought to suppress their dissemination, leading to conflicts between scientists and the Church. The conflict between science and religion in the Enlightenment era reflected broader societal changes, including the rise of democracy, individualism, and secularism. Enlightenment thinkers sought to liberate humanity from the constraints of traditional religious dogma and superstition, advocating for the separation of church and state and the autonomy of scientific inquiry. This secular worldview clashed with religious beliefs about divine revelation, moral authority, and the nature of truth. Moreover, the conflict between science and religion in the Enlightenment era was fueled by social and political factors, including the power struggles between religious institutions and secular authorities. Religious leaders viewed scientific advancements as threats to their authority and sought to suppress dissenting voices within their ranks. Conversely, secular intellectuals saw religion as a barrier to progress and enlightenment, advocating for the relegation of religious beliefs to the private sphere. The conflict between science and religion during the Enlightenment era had profound implications for the course of Western civilization and the development of modern thought. It paved the way for the secularization of society and the emergence of secular humanism as an alternative to traditional religious worldviews. The Enlightenment legacy of skepticism, reason, and empiricism continues to shape contemporary debates about the role of religion in public life and the limits of scientific inquiry. Furthermore, the conflict between science and religion in the Enlightenment era highlighted the tension between faith and reason, belief and skepticism. Enlightenment thinkers sought to reconcile religious faith with scientific rationalism, advocating for a more nuanced understanding of the relationship between science and religion. However, the polarization of intellectual discourse often led to entrenched positions and ideological conflict, hindering efforts to find common ground. In addition, the conflict between science and religion during the Enlightenment era underscored the importance of intellectual freedom and open inquiry in the pursuit of knowledge. Enlightenment thinkers championed the principles of free speech, academic freedom, and scientific autonomy as essential safeguards against dogma and tyranny. Their commitment to the unfettered exchange of ideas laid the groundwork for the scientific revolution and the advancement of human knowledge. Moreover, the conflict between science and religion in the Enlightenment era spurred new approaches to understanding the natural world, including the development of naturalistic explanations for natural phenomena. Enlightenment thinkers rejected supernatural explanations in favor of natural laws and mechanisms, seeking to demystify the universe and dispel superstition. This shift towards secularism and naturalism laid the foundation for modern science and the scientific method. Furthermore, the conflict between science and religion during the Enlightenment era prompted scholars to reconsider the relationship between scientific knowledge and religious belief. While some embraced a strictly secular worldview, others sought to reconcile scientific discoveries with religious faith, advocating for a more harmonious integration of science and religion. This ongoing dialogue continues to shape contemporary discussions about the compatibility of faith and reason in the modern world. In addition, the conflict between science and religion during the Enlightenment era raised questions about the limits of human knowledge and the nature of truth. Enlightenment thinkers grappled with epistemological issues such as skepticism, relativism, and empiricism, seeking to establish a foundation for knowledge that transcended religious authority. Their efforts to establish rational criteria for truth and evidence laid the groundwork for the scientific revolution and the development of modern scientific methodologies. Moreover, the conflict between science and religion during the Enlightenment era highlighted the need for mutual respect and tolerance in intellectual discourse. Enlightenment thinkers recognized the importance of pluralism and diversity in the pursuit of knowledge, advocating for the free exchange of ideas across religious, cultural, and ideological boundaries. Their commitment to open inquiry and intellectual freedom continues to inspire scholars and scientists to engage in respectful dialogue and debate. Furthermore, the conflict between science and religion during the Enlightenment era spurred efforts to redefine the boundaries between the natural and the supernatural, the material and the spiritual. Enlightenment thinkers sought to demystify religious beliefs and practices, advocating for a more rational and empirical approach to understanding the human experience. This secularization of knowledge paved the way for the emergence of modern secular humanism and the decline of religious authority in public life. Lastly, the conflict between science and religion during the Enlightenment era challenged individuals to grapple with existential questions about the nature of existence and the meaning of life. Enlightenment thinkers rejected traditional religious answers to these questions, advocating for a more humanistic and rationalistic approach to understanding the human condition. Their efforts to reconcile science and religion continue to inform contemporary debates about the nature of reality and the role of faith in shaping human values and beliefs. The evolution of modern scientific methodology has been shaped by centuries of inquiry, experimentation, and refinement. During the Enlightenment era, thinkers such as Francis Bacon and René Descartes laid the groundwork for the development of the scientific method, advocating for systematic observation, experimentation, and empirical evidence as the basis for knowledge. Their emphasis on rational inquiry and skepticism challenged traditional modes of thinking and paved the way for a new era of scientific discovery. In the centuries that followed, scientists such as Galileo Galilei, Isaac Newton, and Charles Darwin further refined the scientific method, applying it to diverse fields such as physics, astronomy, and biology. Galileo's use of the telescope to observe the heavens, Newton's formulation of the laws of motion and universal gravitation, and Darwin's theory of evolution by natural selection revolutionized our understanding of the natural world and the processes that govern it. The scientific method is based on several key principles, including empiricism, objectivity, and falsifiability. Scientists formulate hypotheses based on observations and previous knowledge, design experiments to test these hypotheses, and analyze the results to draw conclusions. This iterative process allows scientists to refine their understanding of natural phenomena and develop theories that accurately explain and predict observable phenomena. Moreover, the scientific method relies on peer review and reproducibility to ensure the reliability and validity of scientific findings. Scientists submit their research findings to peer-reviewed journals, where they undergo rigorous scrutiny by experts in the field before publication. This process helps to identify errors, biases, and inconsistencies in research methods and conclusions, ensuring that scientific knowledge is robust and trustworthy. Furthermore, the evolution of modern scientific methodology has been influenced by advances in technology and instrumentation. The development of new tools and techniques, such as microscopes, telescopes, and particle accelerators, has enabled scientists to explore the natural world at ever-increasing levels of detail and precision. These technological advancements have revolutionized fields such as genetics, cosmology, and neuroscience, opening up new avenues for scientific inquiry and discovery. In addition, the scientific method encourages interdisciplinary collaboration and the integration of diverse perspectives and methodologies. Scientists from different fields often collaborate on research projects, bringing together expertise from areas such as physics, chemistry, biology, and computer science. This interdisciplinary approach fosters innovation and creativity, leading to breakthroughs that would not be possible within the confines of a single discipline. Moreover, the evolution of modern scientific methodology has been characterized by a shift towards open science and data sharing. Scientists increasingly make their research data and findings publicly available, allowing other researchers to replicate experiments and verify results. This transparency promotes accountability and reproducibility in scientific research, enhancing the reliability and trustworthiness of scientific knowledge. Furthermore, the scientific method encourages scientists to remain open to new evidence and to revise their theories in light of new data. Scientific knowledge is provisional and subject to revision based on empirical evidence and logical reasoning. This commitment to intellectual humility and skepticism ensures that scientific theories are continually tested and refined, leading to a deeper and more accurate understanding of the natural world. In addition, the evolution of modern scientific methodology has been shaped by efforts to address biases and disparities in scientific research. Scientists increasingly recognize the importance of diversity and inclusion in the scientific community, both in terms of demographics and perspectives. Efforts to promote diversity, equity, and inclusion in science aim to ensure that scientific knowledge reflects the full range of human experiences and perspectives. Moreover, the evolution of modern scientific methodology has been influenced by ethical considerations and concerns about the societal impact of scientific research. Scientists are increasingly mindful of the potential ethical implications of their work, particularly in fields such as biotechnology, artificial intelligence, and climate science. Efforts to promote responsible conduct in research and to engage with stakeholders in the development and dissemination of scientific knowledge are essential for ensuring that science serves the public good. Furthermore, the evolution of modern scientific methodology has been driven by a growing recognition of the importance of science communication and public engagement. Scientists are increasingly engaging with policymakers, journalists, and the public to communicate their findings and to foster informed dialogue about scientific issues. Efforts to promote scientific literacy and critical thinking are essential for empowering individuals to make informed decisions about complex scientific issues. In addition, the evolution of modern scientific methodology has been shaped by efforts to address reproducibility and replicability concerns in scientific research. Scientists are increasingly implementing robust experimental designs and transparent reporting practices to enhance the reliability and validity of their findings. Efforts to promote open science and data sharing are also essential for ensuring that research findings can be independently verified and replicated. Moreover, the evolution of modern scientific methodology has been influenced by the globalization of scientific research and collaboration. Scientists from around the world are increasingly collaborating on research projects, sharing data and expertise across international borders. This globalization of scientific research has led to breakthroughs in fields such as genomics, climate science, and particle physics, advancing our understanding of the natural world and addressing global challenges. Furthermore, the evolution of modern scientific methodology has been characterized by a growing emphasis on interdisciplinary research and the integration of multiple perspectives and methodologies. Scientists are increasingly working across disciplinary boundaries to tackle complex scientific questions that cannot be addressed within the confines of a single field. This interdisciplinary approach fosters innovation and creativity, leading to new insights and discoveries that transcend traditional disciplinary boundaries. The shift from geocentrism to heliocentrism marked a significant paradigm shift in our understanding of the cosmos. For centuries, the geocentric model, which placed Earth at the center of the universe, dominated Western cosmology. This view was deeply rooted in religious and philosophical beliefs about humanity's central place in the cosmos and the immutability of the heavens. The heliocentric model, proposed by astronomers such as Nicholas Copernicus and later refined by Galileo Galilei and Johannes Kepler, challenged the geocentric worldview by positing that the Earth orbits the Sun. This revolutionary idea overturned centuries of entrenched dogma and sparked intense debate among scholars and religious authorities. Copernicus's heliocentric model was based on mathematical calculations and observations of planetary motion, which suggested that the apparent retrograde motion of the planets could be explained by their orbits around the Sun. This paradigm-shifting theory laid the groundwork for the later development of modern astronomy and the scientific revolution. Galileo's observations through his telescope provided further evidence in support of the heliocentric model, such as the phases of Venus and the moons of Jupiter. These empirical findings challenged the geocentric worldview and provided compelling evidence for the motion of the Earth around the Sun. Kepler's laws of planetary motion, which described the elliptical orbits of the planets around the Sun, provided a theoretical framework for understanding the dynamics of the solar system within the heliocentric model. Kepler's laws represented a departure from the geocentric cosmology of Aristotle and Ptolemy, laying the foundation for modern celestial mechanics. The shift from geocentrism to heliocentrism had profound implications for our understanding of the cosmos and our place within it. It challenged religious and philosophical beliefs about humanity's central role in the universe and the stability of the heavens, leading to a re-evaluation of traditional cosmological frameworks. Moreover, the shift from geocentrism to heliocentrism transformed our understanding of planetary motion and the dynamics of the solar system. The heliocentric model provided a more elegant and parsimonious explanation for the observed phenomena, such as the retrograde motion of the planets and the phases of Venus, than the geocentric model. Furthermore, the shift from geocentrism to heliocentrism sparked a renaissance in observational astronomy and mathematical physics, as scientists sought to refine and expand upon Copernicus's revolutionary ideas. The development of new telescopes and mathematical techniques allowed astronomers to make increasingly accurate measurements of planetary positions and motions, further confirming the heliocentric model. In addition, the shift from geocentrism to heliocentrism challenged prevailing religious and theological doctrines, leading to conflicts between scientists and religious authorities. Religious leaders condemned the heliocentric theory as heretical and contrary to Scripture, leading to the persecution and censorship of proponents of the new cosmology. Moreover, the shift from geocentrism to heliocentrism prompted a reassessment of the relationship between science and religion and the boundaries of scientific inquiry. It raised questions about the authority of religious texts in matters of natural philosophy and the autonomy of scientific reasoning in the search for truth. Furthermore, the shift from geocentrism to heliocentrism laid the foundation for the development of modern astronomy and cosmology, as scientists sought to unravel the mysteries of the universe using empirical observation and mathematical reasoning. It paved the way for the scientific revolution and the emergence of a new worldview based on reason, evidence, and rational inquiry. In addition, the shift from geocentrism to heliocentrism challenged human perceptions of the cosmos and our place within it. It forced us to confront the notion that Earth is not the center of the universe and that our existence is not privileged or exceptional in cosmic terms. Moreover, the shift from geocentrism to heliocentrism sparked a paradigm shift in our understanding of the nature of scientific knowledge and the process of scientific discovery. It demonstrated the power of observation, experimentation, and theoretical reasoning in uncovering the hidden truths of the natural world. Furthermore, the shift from geocentrism to heliocentrism inspired generations of scientists and thinkers to question accepted beliefs and to pursue knowledge with courage and curiosity. It exemplified the transformative potential of scientific inquiry in reshaping our understanding of reality and our place within it. The Big Bang Theory provides a scientific explanation for the origin and evolution of the universe. According to this theory, the universe began as a hot, dense singularity approximately 13.8 billion years ago. In the moments following the Big Bang, the universe underwent rapid expansion and cooling, giving rise to the formation of matter, energy, and the fundamental forces of nature. As the universe expanded and cooled, subatomic particles such as protons, neutrons, and electrons began to form. In the first few minutes after the Big Bang, nuclear fusion reactions occurred, producing light elements such as hydrogen, helium, and lithium. These primordial elements eventually gave rise to the formation of stars, galaxies, and the cosmic structures we observe today. The discovery of cosmic microwave background radiation in 1965 provided compelling evidence in support of the Big Bang theory. This faint glow of radiation, which permeates the universe, is a remnant of the intense heat produced by the early universe and serves as a snapshot of the universe's infancy. Moreover, observations of the large-scale structure of the universe, such as the distribution of galaxies and the cosmic microwave background, have provided further confirmation of the Big Bang theory. The observed expansion of the universe, as evidenced by the redshift of distant galaxies, is consistent with the predictions of the Big Bang model. Furthermore, the Big Bang theory has been successful in explaining many key features of the universe, such as the abundance of light elements, the cosmic microwave background radiation, and the large-scale structure of the cosmos. It has also provided a framework for understanding the evolution of galaxies, stars, and planetary systems over billions of years. In addition, the Big Bang theory has inspired ongoing research and exploration in fields such as cosmology, particle physics, and astrophysics. Scientists continue to study the early universe using advanced telescopes and particle accelerators, seeking to unravel the mysteries of cosmic inflation, dark matter, and dark energy. Moreover, the Big Bang theory has profound implications for our understanding of the nature of time, space, and existence. It suggests that the universe has a finite age and has evolved over time, challenging traditional religious and philosophical beliefs about the eternal nature of the cosmos. Furthermore, the Big Bang theory has stimulated philosophical and theological reflections on the ultimate origin and purpose of the universe. It raises questions about the existence of a pre-existing state or cause beyond the observable universe, and the possibility of multiple universes or dimensions beyond our own. In addition, the Big Bang theory has sparked debates about the role of chance, necessity, and purpose in the unfolding of cosmic evolution. It invites us to contemplate the possibility of a universe governed by natural laws and physical processes, rather than divine intervention or supernatural forces. Moreover, the Big Bang theory has inspired awe and wonder at the vastness and complexity of the universe and our place within it. It invites us to marvel at the intricate dance of galaxies, stars, and planets that has unfolded over billions of years, shaping the cosmic tapestry of existence. Furthermore, the Big Bang theory challenges us to confront the limits of human knowledge and understanding in the face of cosmic mysteries. It reminds us of the humility of our scientific endeavors and the ongoing quest to unravel the secrets of the universe. In addition, the Big Bang theory underscores the interconnectedness of all phenomena and the unity of the cosmos. It suggests that the universe emerged from a singular event, binding together all matter, energy, and space-time in a cosmic web of existence. Moreover, the Big Bang theory invites us to contemplate the possibility of a universe teeming with life and diversity, awaiting discovery and exploration. It encourages us to embrace the wonder of cosmic exploration and the pursuit of knowledge about our place in the vastness of space and time. Cosmological constants are fundamental physical constants that determine the properties of the universe. These constants govern the behavior of matter, energy, and space-time on cosmic scales, shaping the structure and evolution of the cosmos. Examples of cosmological constants include the gravitational constant, the speed of light, and the cosmological constant itself, which represents the energy density of empty space. Fine-tuning arguments are philosophical and theological arguments that suggest the universe's physical constants and parameters are finely tuned to allow for the existence of life. Proponents of fine-tuning argue that small deviations in these constants would render the universe inhospitable to life as we know it, leading to the conclusion that the universe was designed or guided by an intelligent creator. Moreover, the fine-tuning of cosmological constants has been cited as evidence for the existence of a cosmic designer or creator. Some theologians and philosophers argue that the precise values of these constants point to a universe that was intelligently designed to support the emergence of life. They see the fine-tuning of the universe as evidence of divine purpose and intentionality in the cosmos. Furthermore, fine-tuning arguments have sparked debates within the scientific community about the nature and significance of cosmic coincidences. Some scientists argue that the apparent fine-tuning of cosmological constants can be explained by natural processes such as cosmic inflation, multiverse theories, or anthropic reasoning without the need for invoking a cosmic designer. In addition, proponents of naturalistic explanations for cosmic fine-tuning point to the possibility of a multiverse, where an infinite number of universes with different physical constants exist. According to this hypothesis, our universe's finely tuned parameters are simply a result of the anthropic principle, which states that only universes compatible with the existence of observers like us can be observed. Moreover, multiverse theories propose that the observed fine-tuning of cosmological constants is a natural consequence of the vast cosmic landscape, where different regions of the multiverse have different physical properties. In this view, the apparent fine-tuning of our universe's constants is a statistical inevitability, rather than evidence of cosmic design. Furthermore, anthropic reasoning suggests that the values of cosmological constants are not fixed by design, but are rather constrained by the requirement for the existence of observers like us. In other words, if the physical constants were different, life as we know it would not exist, and we would not be here to observe them. In addition, anthropic arguments caution against drawing metaphysical conclusions from apparent cosmic coincidences, arguing that the fine-tuning of cosmological constants may be a selection effect rather than evidence of cosmic design. They emphasize the importance of empirical evidence and testable hypotheses in evaluating scientific explanations for cosmic phenomena. Moreover, the debate over cosmic fine-tuning underscores the complex interplay between science, philosophy, and theology in addressing fundamental questions about the nature and origin of the universe. It highlights the limitations of human knowledge and the challenges of interpreting cosmic phenomena within different intellectual frameworks. Furthermore, the study of cosmological constants and fine-tuning arguments continues to stimulate interdisciplinary research and debate in fields such as cosmology, physics, philosophy, and theology. Scientists and scholars from diverse disciplines seek to understand the implications of cosmic fine-tuning for our understanding of the universe and our place within it. In addition, the search for naturalistic explanations for cosmic fine-tuning reflects the scientific community's commitment to methodological naturalism and empirical inquiry. Scientists strive to develop testable hypotheses and observational evidence that can shed light on the underlying mechanisms responsible for the observed properties of the universe. Moreover, the exploration of cosmic fine-tuning invites us to contemplate the profound mystery of existence and the limits of human understanding. It challenges us to grapple with fundamental questions about the nature of reality, the existence of a cosmic purpose, and the ultimate origins of the cosmos. Furthermore, the study of cosmological constants and fine-tuning arguments encourages us to adopt a spirit of humility and intellectual curiosity in our quest for knowledge about the universe. It reminds us of the inherent complexity and mystery of cosmic phenomena, and the importance of approaching these questions with an open mind and a willingness to explore diverse perspectives. Multiverse hypotheses propose the existence of multiple universes, each with its own set of physical laws and constants. According to these theories, our universe is just one of many in a vast cosmic landscape, each with its own unique properties and conditions. Multiverse hypotheses have been proposed to explain various features of the universe, such as the fine-tuning of cosmological constants, the nature of quantum mechanics, and the origin of the universe itself. Moreover, Multiverse theories have profound implications for our understanding of the nature of reality and the existence of a cosmic creator. Some theologians and philosophers argue that the existence of a multiverse is compatible with religious beliefs about the existence of a divine creator who governs the cosmos. They see the multiverse as a manifestation of divine creativity and abundance, reflecting the infinite possibilities inherent in the divine nature. Furthermore, multiverse hypotheses challenge traditional religious conceptions of the universe as a singular, purposeful creation. They suggest that our universe is just one of countless others, in an infinite expanse of space and time, with no special significance or privileged status. This perspective raises questions about the uniqueness of humanity and the role of humanity in the cosmic order. In addition, multiverse theories have sparked debates within religious communities about the implications of a multiverse for traditional theological doctrines. Some theologians embrace the idea of a multiverse as a way of reconciling scientific discoveries with religious beliefs, seeing it as an opportunity to expand our understanding of the divine and the cosmos. Moreover, the existence of a multiverse raises questions about the nature of divine providence and the purpose of existence. If there are countless universes with different physical laws and conditions, what does this mean for the concept of a universe created with a specific purpose in mind? How do we reconcile the apparent randomness and contingency of the multiverse with religious notions of divine sovereignty and providential care? Furthermore, multiverse hypotheses challenge human perceptions of the universe as a coherent, orderly system governed by predictable laws and principles. They suggest that the universe may be far more complex and diverse than we can possibly imagine, with infinite variations and possibilities beyond our comprehension. This perspective invites us to adopt a more humble and open-minded approach to questions about the nature of reality and existence. In addition, the exploration of multiverse hypotheses encourages us to reconsider traditional religious narratives about the origins and nature of the cosmos. It invites us to embrace a more expansive and inclusive understanding of the divine, one that accommodates the vastness and diversity of the multiverse. Moreover, the study of multiverse hypotheses fosters interdisciplinary dialogue and collaboration between scientists, theologians, philosophers, and ethicists. It encourages us to explore the intersection of science, religion, and philosophy in addressing fundamental questions about the nature of reality and our place within it. Furthermore, multiverse theories challenge us to rethink our assumptions about the limits of human knowledge and understanding. They remind us of the inherent mystery and complexity of the universe, and the importance of remaining open to new ideas and perspectives. In addition, the exploration of multiverse hypotheses invites us to contemplate the possibility of a universe teeming with life and diversity, awaiting discovery and exploration. It challenges us to expand our horizons and imagine the vast cosmic tapestry of existence beyond the confines of our own universe. Moreover, the study of multiverse hypotheses encourages us to adopt a spirit of curiosity and wonder in our quest to understand the cosmos. It reminds us of the infinite possibilities inherent in the universe and the endless mysteries waiting to be uncovered. Furthermore, multiverse theories inspire us to embrace the interconnectedness of all things and the unity of the cosmos. They invite us to recognize the beauty and complexity of existence in all its forms, from the smallest subatomic particles to the vast expanses of space and time. In addition, the exploration of multiverse hypotheses encourages us to cultivate a sense of reverence and awe for the mystery and wonder of the universe. It reminds us of the profound privilege of being able to contemplate the nature of reality and existence, and the responsibility we have to steward the cosmic inheritance we have been given. The concept of eternal inflation is a hypothesis in cosmology that suggests the existence of an infinite and ever-expanding multiverse. According to this theory, our universe is just one of many bubble universes that continuously emerge and expand within a larger inflating space-time. Eternal inflation posits that the process of cosmic inflation, which occurred in the early universe, is ongoing, and gives rise to an infinite number of universes with different physical properties and constants. Moreover, eternal inflation challenges traditional notions of cosmic origins and the concept of a singular beginning to the universe. It suggests that our universe may be just one of countless others in an endless cosmic expanse with no definitive starting point or endpoint. This perspective raises profound questions about the nature of existence and the ultimate origins of reality. Furthermore, the concept of eternal inflation has sparked philosophical debates about the nature of time, causality, and contingency. It challenges our intuitive understanding of time as a linear progression from past to future, suggesting that time may be far more complex and multidimensional than we can imagine. Eternal inflation raises questions about the possibility of causality loops and infinite regressions, where causes and effects become intertwined in a never-ending cycle. In addition, eternal inflation invites us to reconsider traditional notions of cosmic purpose and teleology. If the universe is infinite and eternal, what does this mean for the idea of a universe created with a specific purpose or goal in mind? How do we reconcile the apparent randomness and contingency of the multiverse with religious or philosophical notions of divine providence or cosmic order? Moreover, the concept of eternal inflation has profound implications for our understanding of the nature of reality and existence. It challenges us to grapple with questions about the ultimate origins of the cosmos and the fundamental principles that govern the universe. Eternal inflation invites us to contemplate the possibility of a reality that transcends our current understanding, and to explore the mysteries of existence with an open mind and a spirit of curiosity. Furthermore, eternal inflation raises questions about the nature of consciousness and the role of observers in shaping reality. If there are infinite universes with different physical laws and constants, what does this mean for the existence of conscious beings like ourselves? How do we reconcile the apparent fine-tuning of the universe with the existence of an infinite multiverse? In addition, eternal inflation challenges us to rethink our assumptions about the nature of existence and the limits of human knowledge. It reminds us of the inherent uncertainty and complexity of the universe and the importance of remaining open to new ideas and perspectives. Eternal inflation invites us to embrace a spirit of humility and intellectual curiosity in our quest to understand the mysteries of the cosmos. Moreover, the concept of eternal inflation encourages us to explore the implications of the multiverse hypothesis for our understanding of reality and existence. It challenges us to consider the possibility of a universe teeming with life and diversity, awaiting discovery and exploration. Eternal inflation invites us to imagine the vast cosmic tapestry of existence beyond the confines of our own universe and to contemplate our place within it. Furthermore, eternal inflation inspires us to embrace the interconnectedness of all things and the unity of the cosmos. It invites us to recognize the beauty and complexity of existence in all its forms, from the smallest subatomic particles to the vast expanses of space and time. Eternal inflation encourages us to cultivate a sense of reverence and awe for the mystery and wonder of the universe. In addition, the concept of eternal inflation encourages us to consider the ethical implications of our actions in a potentially infinite and interconnected cosmos. It challenges us to think about the long-term consequences of our decisions and to consider the welfare of future generations and other sentient beings. Eternal inflation invites us to adopt a holistic and compassionate approach to life and to strive for harmony and balance in our interactions with the universe. Moreover, eternal inflation prompts us to reflect on the ultimate meaning and purpose of existence in a vast and ever-expanding multiverse. It encourages us to seek wisdom and insight from diverse sources, including science, philosophy, and spirituality, in our quest to understand the mysteries of the cosmos. Eternal inflation invites us to embrace the journey of exploration and discovery with an open heart and a spirit of wonder. Theoretical frameworks for understanding the universe's structure encompass a diverse range of scientific models and theories that seek to explain the observed properties and behavior of the cosmos. These frameworks draw upon principles from physics, astronomy, and cosmology to develop comprehensive descriptions of the universe at various scales, from the smallest subatomic particles to the largest cosmic structures. One such theoretical framework is general relativity, proposed by Albert Einstein in 1915, which describes the gravitational interactions between matter and space-time. General relativity provides a geometric interpretation of gravity, where massive objects warp the fabric of space-time, causing other objects to follow curved paths. This theory has been instrumental in understanding the large-scale structure of the universe, including the formation of galaxies, clusters of galaxies, and cosmic filaments. Another important theoretical framework is quantum mechanics, which describes the behavior of particles at the subatomic level. Quantum mechanics introduces probabilistic phenomena such as wave-particle duality and uncertainty principles, which govern the behavior of particles on microscopic scales. This framework is essential for understanding the fundamental forces and particles that govern the behavior of matter and energy in the universe. Moreover, theoretical frameworks such as quantum field theory and the Standard Model of particle physics provide a comprehensive description of the fundamental forces and particles that make up the universe. Quantum field theory combines quantum mechanics with special relativity to describe the behavior of particles and fields, while the Standard Model classifies the known elementary particles and their interactions. In addition, theoretical frameworks such as inflationary cosmology and string theory offer explanations for the origin and evolution of the universe on cosmic scales. Inflationary cosmology proposes that the universe underwent a period of rapid expansion in the early moments of its existence, leading to the formation of large-scale structures such as galaxies and galaxy clusters. String theory, on the other hand, seeks to unify the fundamental forces of nature by describing them in terms of vibrating strings and higher dimensional spaces. Furthermore, theoretical frameworks such as dark matter and dark energy provide explanations for the observed properties of the universe that cannot be accounted for by known forms of matter and energy. Dark matter is believed to constitute the majority of the mass in the universe and plays a crucial role in the formation and evolution of cosmic structures. Dark energy, on the other hand, is thought to be responsible for the observed acceleration of the universe's expansion. Moreover, theoretical frameworks such as the cosmic microwave background radiation and large-scale structure formation provide insights into the early history and evolution of the universe. The cosmic microwave background radiation is a faint glow of radiation that permeates the universe, originating from the hot, dense state of the early universe. Observations of the cosmic microwave background provide valuable information about the universe's age, composition, and geometry. In addition, theoretical frameworks such as the inflationary model of the universe's origin offer explanations for the observed uniformity and flatness of the universe on large scales. The inflationary model proposes that the universe underwent a period of rapid expansion in the first fraction of a second after the Big Bang, smoothing out any irregularities and producing a flat, homogeneous universe. Moreover, theoretical frameworks such as the anthropic principle and the multiverse hypothesis offer explanations for the observed fine-tuning of the universe's physical constants and parameters. The anthropic principle suggests that the universe's properties must be compatible with the existence of observers like us, while the multiverse hypothesis posits that our universe is just one of many in a vast cosmic landscape, each with its own set of physical laws and constants. Furthermore, theoretical frameworks such as brane cosmology and loop quantum gravity offer alternative descriptions of the universe's structure and evolution. Brane cosmology proposes that our universe is a four-dimensional brane embedded in a higher dimensional space, while loop quantum gravity seeks to reconcile general relativity with quantum mechanics by quantizing space-time itself. In addition, theoretical frameworks such as holographic principle and emergent gravity offer new perspectives on the nature of space, time, and gravity. The holographic principle suggests that the information content of a three-dimensional region of space can be encoded on its two-dimensional boundary, while emergent gravity proposes that gravity is an emergent phenomenon that arises from the collective behavior of underlying quantum degrees of freedom. Moreover, theoretical frameworks such as quantum cosmology and eternal inflation provide insights into the ultimate fate of the universe and the nature of cosmic beginnings and endings. Quantum cosmology seeks to describe the universe's origin and evolution using principles from quantum mechanics and general relativity, while eternal inflation suggests that our universe is just one of countless others in an ever-expanding multiverse. Furthermore, theoretical frameworks such as superstring theory and M-theory offer unified descriptions of the fundamental forces and particles that govern the universe. Superstring theory posits that the fundamental building blocks of the universe are tiny, vibrating strings, while M-theory extends this framework to include additional dimensions and symmetries. In addition, theoretical frameworks such as cosmic inflation and the holographic principle provide insights into the early history and evolution of the universe. Cosmic inflation proposes that the universe underwent a rapid period of expansion in the first fraction of a second after the Big Bang, smoothing out any irregularities and producing a flat, homogeneous universe. The holographic principle suggests that the information content of a three-dimensional region of space can be encoded on its two-dimensional boundary, offering a new perspective on the nature of space, time, and gravity. The compatibility between science and religious beliefs has been a topic of debate for centuries. While some see science and religion as inherently conflicting, others argue that they can coexist harmoniously and even complement each other. Proponents of compatibility point to the shared goals of both disciplines, such as seeking to understand the nature of reality and the origins of the universe. They argue that science and religion address different aspects of human experience and can offer complementary perspectives on fundamental questions about existence. Moreover, proponents of compatibility argue that many scientific discoveries have been made by individuals who were motivated by religious beliefs or inspired by religious teachings. They point to historical examples such as Isaac Newton, whose groundbreaking work in physics was influenced by his Christian faith, and Gregor Mendel, whose pioneering studies in genetics were guided by his religious convictions. These examples suggest that science and religion can inspire and inform each other, leading to new insights and discoveries. Furthermore, proponents of compatibility emphasize that many religious traditions incorporate symbolic and metaphorical interpretations of sacred texts, which can accommodate scientific discoveries and insights. They argue that religious beliefs should not be interpreted literally, but rather as metaphorical expressions of deeper spiritual truths. From this perspective, scientific discoveries can enrich and deepen our understanding of religious teachings rather than undermining them. In addition, proponents of compatibility argue that science and religion operate in different domains of inquiry and use different methodologies to investigate the nature of reality. While science relies on empirical observation, experimentation, and logical reasoning, religion often appeals to faith, revelation, and spiritual experience. They suggest that these different approaches can complement each other, offering distinct but valuable perspectives on the human condition. Moreover, proponents of compatibility point to religious traditions that embrace scientific inquiry and encourage their followers to seek knowledge about the natural world. They argue that many religious beliefs are not incompatible with scientific findings, but rather provide a framework for understanding and interpreting the mysteries of existence. From this perspective, science and religion can be seen as complementary ways of exploring and understanding reality. Furthermore, proponents of compatibility argue that science and religion share a common goal of promoting human flourishing and addressing existential questions about the meaning and purpose of life. They suggest that both disciplines can offer insights into ethical and moral issues and provide guidance for navigating the complexities of the human experience. From this perspective, science and religion can work together to foster a deeper understanding of the human condition and promote values such as compassion, empathy, and justice. In addition, proponents of compatibility point to the diversity of religious beliefs and practices around the world, which encompass a wide range of perspectives on the relationship between science and religion. They argue that there is no single monolithic view of this relationship within religious traditions, but rather a spectrum of beliefs and interpretations. From this perspective, it is possible to find common ground between science and religion, and to embrace a pluralistic approach that respects different ways of knowing and understanding the world. Moreover, proponents of compatibility highlight the role of dialogue and engagement between scientists and religious scholars in fostering mutual understanding and respect. They argue that open and respectful communication can help bridge the perceived gap between science and religion and promote collaboration in addressing shared concerns such as environmental sustainability, social justice, and human well-being. From this perspective, science and religion can be seen as partners in the quest for truth and wisdom. Furthermore, proponents of compatibility emphasize the importance of humility and intellectual humility in navigating the complex relationship between science and religion. They argue that both disciplines are limited in their ability to provide definitive answers to ultimate questions about existence, and that a spirit of openness and curiosity is essential for genuine exploration and discovery. From this perspective, science and religion can be seen as complementary pathways to deeper understanding and insight. In addition, proponents of compatibility point to examples of religious communities that have embraced scientific advances and integrated them into their worldview. They argue that many religious traditions are not inherently opposed to scientific inquiry, but rather encourage their followers to seek knowledge and wisdom from diverse sources. From this perspective, science and religion can be seen as mutually enriching and supportive endeavors that contribute to human flourishing and well-being. Moreover, proponents of compatibility suggest that science and religion both offer frameworks for understanding and interpreting the mysteries of existence, each with its own strengths and limitations. They argue that a holistic approach that integrates insights from both disciplines can provide a more comprehensive and nuanced understanding of reality. From this perspective, science and religion can be seen as complementary aspects of a broader quest for meaning and understanding in the universe. Theistic interpretations of scientific discoveries offer perspectives that integrate religious beliefs with empirical observations and theoretical frameworks. These interpretations often seek to reconcile scientific findings with theological doctrines and spiritual teachings, providing a framework for understanding the natural world within a religious context. Moreover, theistic interpretations emphasize the idea that the universe is the product of divine creation, guided by a transcendent intelligence or higher power. They suggest that scientific discoveries, such as the Big Bang theory or the theory of evolution, are compatible with the concept of a creator who designed and sustains the cosmos. From this perspective, scientific discoveries can be seen as revealing the intricacy and complexity of the divine plan. Furthermore, theistic interpretations of scientific discoveries often emphasize the idea of divine revelation, where religious texts and spiritual teachings provide insights into the nature of reality and the workings of the universe. They argue that scientific discoveries can be understood in light of religious truths, offering a deeper understanding of the mysteries of existence and the purpose of life. In addition, theistic interpretations of scientific discoveries highlight the concept of divine providence, where the universe is seen as unfolding according to a divine plan or purpose. They suggest that scientific discoveries, such as the fine-tuning of cosmological constants or the emergence of life on Earth, reflect the handiwork of a creator who imbued the universe with order, beauty, and meaning. Moreover, theistic interpretations of scientific discoveries often emphasize the idea of stewardship, where humans are seen as caretakers of the natural world entrusted to them by a divine creator. They argue that scientific knowledge and technological advancements should be used responsibly and ethically, in accordance with religious teachings about compassion, justice, and environmental sustainability. Furthermore, theistic interpretations of scientific discoveries seek to foster a sense of wonder and reverence for the natural world, encouraging individuals to contemplate the beauty and complexity of creation as a reflection of divine wisdom and creativity. They suggest that scientific inquiry can deepen one's appreciation for the mysteries of existence and the interconnectedness of all life. In addition, theistic interpretations of scientific discoveries often emphasize the idea of harmony between faith and reason, where religious beliefs are seen as compatible with empirical evidence and logical reasoning. They argue that science and religion offer complementary ways of understanding reality, each providing valuable insights into the nature of existence and the human condition. Moreover, theistic interpretations of scientific discoveries highlight the concept of transcendence, where the natural world is seen as a manifestation of divine presence and purpose. They suggest that scientific discoveries, such as the laws of physics or the emergence of consciousness, point to the existence of a transcendent reality beyond the material realm. Furthermore, theistic interpretations of scientific discoveries often emphasize the idea of humility, where humans are seen as finite beings grappling with the mysteries of an infinite universe. They argue that scientific knowledge should be pursued with humility and reverence, recognizing the limits of human understanding in the face of the divine mystery. In addition, theistic interpretations of scientific discoveries seek to promote dialogue and engagement between science and religion, fostering mutual respect and cooperation in addressing shared concerns such as ethical dilemmas, existential questions, and societal challenges. They argue that science and religion can work together to promote human flourishing and spiritual growth, offering complementary perspectives on the human experience. Moreover, theistic interpretations of scientific discoveries highlight the importance of spiritual discernment and moral reflection in interpreting scientific findings. They suggest that scientific knowledge should be evaluated in light of ethical principles and spiritual values, guiding individuals in their quest for understanding and wisdom. Furthermore, theistic interpretations of scientific discoveries often emphasize the concept of mystery, where the natural world is seen as a reflection of divine transcendence and ineffability. They argue that scientific discoveries, while illuminating aspects of the universe, can never fully capture the depth and richness of divine reality. In addition, theistic interpretations of scientific discoveries seek to inspire awe and reverence for the natural world, inviting individuals to contemplate the beauty and complexity of creation as a testament to the divine presence. They suggest that scientific inquiry can deepen one's spiritual connection to the cosmos, fostering a sense of wonder and gratitude for the gift of existence. Philosophical arguments for the existence of God from cosmology draw upon observations and principles from the study of the universe to infer the existence of a divine creator or higher power. These arguments seek to demonstrate that the structure and properties of the cosmos are best explained by the existence of a transcendent intelligence or first cause. Moreover, one such argument is the cosmological argument, which posits that the existence of the universe itself implies the existence of a necessary being or first cause that brought it into existence. Proponents of this argument suggest that the universe cannot be self-existent and must have a cause outside of itself, which they identify as God. Furthermore, the cosmological argument is often formulated in different variations, such as the Kalam cosmological argument, which appeals to the idea of a first cause based on the temporal finitude of the universe. Proponents of this argument argue that the universe had a beginning in time and must therefore have a cause outside of time, which they identify as God. In addition, another philosophical argument for the existence of God from cosmology is the teleological argument, which appeals to the apparent design and orderliness of the universe as evidence of a divine creator. Proponents of this argument point to the fine-tuning of cosmological constants, the complexity of biological organisms, and the presence of beauty and harmony in the natural world as indicators of intelligent design. Moreover, the teleological argument is often associated with the concept of the anthropic principle, which suggests that the universe appears to be finely tuned for the emergence of life and conscious observers. Proponents of this argument argue that the fine-tuning of cosmological constants and the conditions necessary for life suggest the existence of a cosmic designer who intended for life to arise. Furthermore, another philosophical argument for the existence of God from cosmology is the argument from contingency, which appeals to the idea that the existence of contingent beings in the universe requires an explanation in terms of a necessary being or first cause. Proponents of this argument argue that the contingent nature of the universe points to the existence of a non-contingent being, which they identify as God. In addition, proponents of the argument from contingency often draw upon the principle of sufficient reason, which suggests that everything that exists or happens must have a reason or cause. They argue that the existence of contingent beings in the universe requires an ultimate explanation in terms of a necessary being, which they identify as God. Moreover, another philosophical argument for the existence of God from cosmology is the argument from cosmological fine-tuning, which appeals to the idea that the precise values of cosmological constants and parameters necessary for the existence of life are unlikely to have occurred by chance. Proponents of this argument argue that the fine-tuning of the universe points to the existence of a cosmic designer who intended for life to arise. Furthermore, the argument from cosmological fine-tuning is often associated with the concept of the multiverse, which suggests that the existence of multiple universes with different properties and conditions may explain the apparent fine-tuning of our universe. However, proponents of the argument from cosmological fine-tuning argue that the multiverse hypothesis itself requires an explanation in terms of a necessary being or first cause, which they identify as God. In addition, proponents of the argument from cosmological fine-tuning often draw upon the principle of inference to the best explanation, which suggests that the best explanation for the fine-tuning of the universe is the existence of a cosmic designer. They argue that the hypothesis of a divine creator provides a more satisfactory explanation for the observed facts than alternative naturalistic explanations. Moreover, another philosophical argument for the existence of God from cosmology is the argument from the origin of the universe, which appeals to the idea that the universe must have had a cause or explanation for its existence. Proponents of this argument argue that the existence of the universe itself requires an ultimate explanation in terms of a necessary being or first cause, which they identify as God. Furthermore, the argument from the origin of the universe is often associated with the concept of the Big Bang theory, which suggests that the universe began from a singularity approximately 13.8 billion years ago. Proponents of this argument argue that the existence of the universe ex nihilo points to the existence of a transcendent cause outside of space and time, which they identify as God. In addition, proponents of the argument from the origin of the universe often draw upon the principle of causality, which suggests that everything that begins to exist must have a cause. They argue that the existence of the universe itself requires an explanation in terms of a necessary being or first cause, which they identify as God. Moreover, another philosophical argument for the existence of God from cosmology is the argument from cosmic order, which appeals to the idea that the universe exhibits a remarkable degree of order, regularity, and predictability. Proponents of this argument argue that the existence of cosmic order points to the existence of a cosmic designer who imbued the universe with purpose and intentionality. Furthermore, the argument from cosmic order is often associated with the concept of natural laws, which describe the fundamental principles that govern the behavior of matter and energy in the universe. Proponents of this argument argue that the existence of natural laws points to the existence of a divine creator who established the order and structure of the cosmos. In addition, proponents of the argument from cosmic order often draw upon the principle of uniformity, which suggests that the laws of nature are consistent and applicable throughout the universe. They argue that the existence of cosmic order points to the existence of a transcendent intelligence or higher power that sustains the universe and governs its operations. Ethical and moral implications of scientific inquiry encompass a broad range of considerations regarding the impact of scientific research and technological advancements on society, individuals, and the natural world. These implications raise profound questions about the ethical responsibilities of scientists, the potential risks and benefits of scientific knowledge, and the moral dimensions of technological innovation. Moreover, one ethical consideration of scientific inquiry is the principle of scientific integrity, which emphasizes honesty, transparency, and objectivity in the conduct of research. Scientists are expected to adhere to rigorous standards of methodological rigor and intellectual honesty, ensuring that their findings are accurate, reliable, and reproducible. Furthermore, another ethical consideration of scientific inquiry is the principle of social responsibility, which emphasizes the importance of considering the broader societal implications of scientific research and technological development. Scientists are encouraged to engage with stakeholders, including policymakers, community members, and affected parties, to ensure that their research serves the public good and addresses pressing societal challenges. In addition, one ethical consideration of scientific inquiry is the principle of respect for human dignity and autonomy, which emphasizes the importance of protecting the rights and welfare of research participants and subjects. Scientists are required to obtain informed consent from participants, respect their privacy and confidentiality, and minimize any potential risks or harms associated with their research. Moreover, another ethical consideration of scientific inquiry is the principle of justice, which emphasizes the fair distribution of the benefits and burdens of scientific research and technological innovation. Scientists are called upon to consider issues of equity, diversity, and inclusion in their research practices, ensuring that the benefits of scientific knowledge are shared equitably across society. Furthermore, one ethical consideration of scientific inquiry is the principle of environmental sustainability, which emphasizes the importance of protecting the health and integrity of the natural world. Scientists are encouraged to consider the ecological impacts of their research and technological developments, minimizing harm to ecosystems and promoting sustainable practices. In addition, another ethical consideration of scientific inquiry is the principle of accountability, which emphasizes the importance of taking responsibility for the ethical and social consequences of scientific research and technological innovation. Scientists are called upon to engage in ongoing reflection and dialogue about the ethical implications of their work, seeking to mitigate any potential risks or unintended consequences. Moreover, one ethical consideration of scientific inquiry is the principle of precaution, which emphasizes the importance of taking proactive measures to anticipate and address potential risks and uncertainties associated with scientific research and technological development. Scientists are encouraged to adopt a precautionary approach to emerging technologies, considering the potential long-term impacts on human health, society, and the environment. Furthermore, another ethical consideration of scientific inquiry is the principle of transparency, which emphasizes the importance of open communication and disclosure of research findings, methodologies, and potential conflicts of interest. Scientists are expected to provide clear and accessible information to the public, policymakers, and other stakeholders, enabling informed decision-making and accountability. In addition, one ethical consideration of scientific inquiry is the principle of inclusivity, which emphasizes the importance of promoting diversity, equity, and inclusion in the scientific community. Scientists are called upon to foster a culture of inclusivity and belonging, ensuring that all individuals have equal opportunities to participate in and contribute to scientific research and innovation. Moreover, another ethical consideration of scientific inquiry is the principle of social justice, which emphasizes the importance of addressing systemic inequalities and injustices in the distribution of scientific resources and opportunities. Scientists are encouraged to advocate for policies and practices that promote equity and justice in the scientific enterprise, including fair access to education, funding, and career advancement. Furthermore, one ethical consideration of scientific inquiry is the principle of cultural sensitivity, which emphasizes the importance of respecting and valuing diverse cultural perspectives and knowledge systems. Scientists are called upon to engage respectfully with indigenous peoples, local communities, and other stakeholders, recognizing the importance of indigenous knowledge and traditions in shaping scientific understanding of the natural world. In addition, another ethical consideration of scientific inquiry is the principle of global responsibility, which emphasizes the importance of addressing global challenges such as climate change, biodiversity loss, and pandemics through collaborative, interdisciplinary research and action. Scientists are called upon to work together across national and disciplinary boundaries to address pressing global issues and promote human well-being. Moreover, one ethical consideration of scientific inquiry is the principle of ethical leadership, which emphasizes the importance of ethical decision-making and responsible conduct of research at all levels of the scientific enterprise. Scientists are encouraged to lead by example, fostering a culture of integrity, accountability, and social responsibility within their research teams and institutions. Furthermore, another ethical consideration of scientific inquiry is the principle of humility, which emphasizes the importance of recognizing the limitations of scientific knowledge and the potential for unintended consequences of scientific research and technological innovation. Scientists are called upon to approach their work with humility and curiosity, acknowledging that there is much that remains unknown and uncertain about the natural world. Scientists' personal beliefs can influence their professional practice in various ways, shaping their research interests, methodologies, and interpretations of data. While scientists strive to maintain objectivity and impartiality in their work, it is inevitable that their personal beliefs, values, and worldview will inform their scientific endeavors to some extent. Moreover, one way in which scientists' personal beliefs can influence their professional practice is through their choice of research topics and questions. Scientists may be drawn to research areas that align with their personal interests, values, or ideological commitments, leading them to prioritize certain topics over others. Furthermore, scientists' personal beliefs can also influence their methodological approaches and experimental designs. For example, scientists who hold certain philosophical or religious convictions may be more inclined to adopt particular research methods or interpretive frameworks that resonate with their worldview. In addition, scientists' personal beliefs can influence their interpretations of data and findings. While scientists strive to adhere to rigorous standards of evidence and logic, it is inevitable that their personal perspectives and biases will shape their understanding of complex phenomena and their conclusions about the implications of their research. Moreover, scientists' personal beliefs can also influence their interactions with colleagues, collaborators, and stakeholders in the scientific community. Scientists who share similar beliefs or values may be more inclined to collaborate or form professional networks with like-minded individuals, while those with divergent perspectives may encounter challenges in communication and collaboration. Furthermore, scientists' personal beliefs can also influence their engagement with broader societal issues and debates. Scientists may choose to advocate for particular policy positions or engage in public discourse on topics related to their expertise, drawing upon their personal values and convictions to inform their advocacy efforts. In addition, scientists' personal beliefs can also influence their attitudes towards ethical and social responsibilities in their professional practice. Scientists who hold strong ethical or moral convictions may be more inclined to prioritize ethical considerations in their research and decision-making processes, while others may adopt a more utilitarian approach that prioritizes scientific progress over ethical concerns. Moreover, scientists' personal beliefs can also influence their career trajectories and professional identities. Scientists who are deeply committed to particular ideological or religious perspectives may seek out research opportunities or positions that align with their beliefs, shaping their professional identities and contributions to the scientific community. Furthermore, scientists' personal beliefs can also influence their attitudes towards interdisciplinary collaboration and engagement with diverse perspectives. Scientists who hold open-minded and inclusive attitudes may be more receptive to collaborating with colleagues from different disciplinary backgrounds or cultural traditions, fostering creativity and innovation in their research endeavors. In addition, scientists' personal beliefs can also influence their attitudes towards skepticism and uncertainty in their professional practice. Scientists who embrace humility and intellectual curiosity may be more willing to acknowledge the limitations of their knowledge and the complexities of the natural world, fostering a spirit of inquiry and exploration in their scientific endeavors. Moreover, scientists' personal beliefs can also influence their approaches to teaching and mentorship in academic settings. Scientists who are passionate about sharing their knowledge and inspiring the next generation of researchers may draw upon their personal beliefs and values to inform their pedagogical approaches and mentorship styles. Furthermore, scientists' personal beliefs can also influence their engagement with controversial or contentious issues in their fields of study. Scientists who hold strong convictions about certain topics may be more inclined to take public positions or advocate for particular policy outcomes, drawing upon their expertise and credibility to influence public opinion and decision-making. In addition, scientists' personal beliefs can also influence their attitudes towards collaboration and competition in the scientific community. Scientists who prioritize collaboration and cooperation may be more inclined to share their findings and resources with colleagues, fostering a culture of openness and mutual support in their professional networks. Moreover, scientists' personal beliefs can also influence their approaches to balancing professional responsibilities with personal values and priorities. Scientists who prioritize family, community, or personal well-being may seek out work-life balance strategies that allow them to pursue their scientific interests while also attending to their personal needs and obligations. Scientific methods for detecting extraterrestrial life involve a diverse array of approaches and techniques aimed at identifying signs of life beyond Earth. These methods draw upon principles from various scientific disciplines, including astronomy, biology, chemistry, and planetary science, to search for evidence of life in the universe. Moreover, one method for detecting extraterrestrial life is through the analysis of atmospheric composition and biosignatures. Scientists use telescopes and spectroscopy to study the composition of exoplanet atmospheres, looking for chemical compounds such as oxygen, methane, and water vapor that could indicate the presence of life. Furthermore, another method for detecting extraterrestrial life is through the study of extremophiles on Earth. Scientists investigate extreme environments such as deep-sea hydrothermal vents, acidic hot springs, and Antarctic ice shelves to identify organisms capable of surviving in harsh conditions, similar to those found on other planets or moons. In addition, one method for detecting extraterrestrial life is through the search for organic molecules and biomarkers in space. Scientists use telescopes and spacecraft to analyze the composition of comets, asteroids, and interstellar clouds, looking for complex organic compounds that could serve as the building blocks of life. Moreover, Another method for detecting extraterrestrial life is through the study of microbial life on Mars. Scientists analyze data from robotic missions, such as the Mars rovers and landers, to search for evidence of past or present microbial activity, including fossilized remains, organic molecules, and potential habitats for life. Furthermore, one method for detecting extraterrestrial life is through the exploration of icy moons in the outer solar system. Scientists study moons such as Europa, Enceladus, and Titan to search for evidence of subsurface oceans, hydrothermal vents, and organic molecules that could support microbial life. In addition, one method for detecting extraterrestrial life is through the study of exoplanet habitability and potential biosignatures. Scientists use computer models and simulations to assess the habitability of exoplanets based on factors such as temperature, atmosphere, and surface conditions, identifying promising targets for future observation and exploration. Moreover, another method for detecting extraterrestrial life is through the analysis of meteorites and interplanetary dust particles. Scientists study samples from asteroids and comets to search for organic molecules, amino acids, and other chemical compounds that could provide clues to the origins of life in the solar system. Furthermore, one method for detecting extraterrestrial life is through the study of planetary atmospheres and climate. Scientists use computer models and remote sensing techniques to simulate the atmospheric dynamics of other planets and moons, identifying potential habitable zones and environmental conditions conducive to life. In addition, one method for detecting extraterrestrial life is through the search for technosignatures and extraterrestrial intelligence. Scientists use radio telescopes and optical instruments to search for signals of intelligent origin, such as radio waves, laser beams, or artificial light sources that could indicate the presence of advanced civilizations elsewhere in the universe. Moreover, another method for detecting extraterrestrial life is through the study of planetary geology and surface features. Scientists analyze images and data from spacecraft missions to study the geological history and evolution of other planets and moons, identifying potential habitats for life and targets for further exploration. Furthermore, one method for detecting extraterrestrial life is through the study of exoplanet transits and eclipses. Scientists use telescopes and spacecraft to monitor changes in the brightness and spectral characteristics of distant stars, looking for periodic dips and fluctuations that could be caused by orbiting planets and their atmospheres. In addition, one method for detecting extraterrestrial life is through the analysis of interstellar dust and gas clouds. Scientists study the chemical composition and physical properties of interstellar material to search for organic molecules, complex carbon compounds, and other prebiotic ingredients that could seed life on other planets and moons. Moreover, another method for detecting extraterrestrial life is through the study of planetary magnetospheres and auroras. Scientists use spacecraft and ground-based observatories to monitor the magnetic fields and charged particles surrounding other planets and moons, identifying potential signatures of biological activity and atmospheric interactions. Furthermore, one method for detecting extraterrestrial life is through the analysis of planetary surface chemistry and mineralogy. Scientists study the composition and distribution of rocks, minerals, and surface features on other planets and moons, looking for evidence of past or present geological processes that could support microbial life. In addition, one method for detecting extraterrestrial life is through the study of exoplanet habitability zones and planetary systems. Scientists use statistical analyses and computer simulations to assess the likelihood of habitable conditions on other planets and moons, identifying promising candidates for future study and exploration. Religious perspectives on the existence of extraterrestrial life vary widely among different faith traditions and theological interpretations. While some religious groups embrace the possibility of extraterrestrial life as compatible with their beliefs, others express skepticism or caution about its implications for religious doctrine and teachings. Moreover, some religious perspectives on the existence of extraterrestrial life emphasize the idea of cosmic pluralism, which suggests that the universe is teeming with diverse forms of life, created by a benevolent and creative deity. Proponents of this view argue that the discovery of extraterrestrial life would affirm the richness and diversity of divine creation, expanding human understanding of God's creative power and wisdom. Furthermore, Other religious perspectives on the existence of extraterrestrial life emphasize the idea of cosmic uniqueness, which suggests that Earth and humanity occupy a special place in God's plan for the universe. Proponents of this view argue that the discovery of extraterrestrial life would challenge traditional theological notions of human exceptionalism and the centrality of Earth in divine revelation. In addition, some religious perspectives on the existence of extraterrestrial life emphasize the idea of theological reconciliation, which seeks to integrate scientific discoveries about the cosmos with religious beliefs and teachings. Proponents of this view argue that the discovery of extraterrestrial life would invite theological reflection and reinterpretation, challenging believers to explore new ways of understanding God's relationship to the universe and humanity's place within it. Moreover, other religious perspectives on the existence of extraterrestrial life emphasize the idea of theological skepticism, which expresses caution or skepticism about the implications of scientific claims regarding the existence of extraterrestrial life. Proponents of this view argue that the discovery of extraterrestrial life could raise theological questions and dilemmas that challenge traditional religious doctrines and beliefs. Furthermore, some religious perspectives on the existence of extraterrestrial life emphasize the idea of ethical responsibility, which emphasizes the importance of ethical and moral considerations in human interactions with extraterrestrial beings. Proponents of this view argue that the discovery of extraterrestrial life would raise ethical questions about humanity's obligations to other intelligent beings and the ethical implications of contact and communication with extraterrestrial civilizations. In addition, other religious perspectives on the existence of extraterrestrial life emphasize the idea of eschatological significance, which suggests that the discovery of extraterrestrial life could have profound implications for religious beliefs about the end times and the ultimate destiny of humanity and the universe. Proponents of this view argue that the discovery of extraterrestrial life could prompt theological reflections on the cosmic significance of human existence and the ultimate purposes of creation. Moreover, some religious perspectives on the existence of extraterrestrial life emphasize the idea of prophetic anticipation, which suggests that religious texts and traditions contain hidden or cryptic references to extraterrestrial beings and civilizations. Proponents of this view argue that the discovery of extraterrestrial life could provide new insights into the interpretation of religious scriptures and the fulfillment of eschatological prophecies. Furthermore, other religious perspectives on the existence of extraterrestrial life emphasize the idea of theological humility, which encourages believers to approach questions about the existence of extraterrestrial life with humility and openness to new insights and interpretations. Proponents of this view argue that the discovery of extraterrestrial life could challenge human arrogance and expand human understanding of God's transcendent mystery and grace. In addition, some religious perspectives on the existence of extraterrestrial life emphasize the idea of spiritual kinship, which suggests that all beings in the universe share a common spiritual essence and divine origin. Proponents of this view argue that the discovery of extraterrestrial life could deepen human appreciation for the interconnectedness of all life and the universal scope of God's love and compassion. Moreover, other religious perspectives on the existence of extraterrestrial life emphasize the idea of theological creativity, which encourages believers to explore imaginative and speculative interpretations of religious teachings in light of scientific discoveries. Proponents of this view argue that the discovery of extraterrestrial life could inspire new theological insights and narratives that enrich religious traditions and deepen human understanding of the divine mystery. Furthermore, some religious perspectives on the existence of extraterrestrial life emphasize the idea of cosmic redemption, which suggests that the discovery of extraterrestrial life could be seen as part of God's plan for the redemption and reconciliation of the entire cosmos. Proponents of this view argue that the discovery of extraterrestrial life could offer new opportunities for spiritual growth and mutual cooperation among diverse beings in the universe. In addition, other religious perspectives on the existence of extraterrestrial life emphasize the idea of theological pluralism, which suggests that different religious traditions and belief systems may offer valid and complementary perspectives on the nature of God and the meaning of existence. Proponents of this view argue that the discovery of extraterrestrial life could foster dialogue and mutual respect among diverse religious communities, enriching human understanding of the divine mystery. Moreover, some religious perspectives on the existence of extraterrestrial life emphasize the idea of ethical stewardship, which encourages believers to approach questions about the ethical implications of contact with extraterrestrial beings with wisdom, compassion, and humility. Proponents of this view argue that the discovery of extraterrestrial life could challenge humanity to embrace its role as caretakers of the cosmos and to cultivate a deeper sense of reverence for the diversity and wonder of gods. Implications of discovering intelligent extraterrestrial life provoke profound questions and considerations across scientific, philosophical, and religious domains. Such a discovery would challenge fundamental assumptions about humanity's place in the universe and our understanding of life, intelligence, and consciousness. Moreover, one implication of discovering intelligent extraterrestrial life is the potential for scientific advancement and expanded knowledge. Studying alien civilizations could provide insights into alternative forms of intelligence, technological development, and societal organization, enhancing our understanding of the cosmos and our place within it. Furthermore, another implication of discovering intelligent extraterrestrial life is the impact on religious beliefs and worldviews. Many religious traditions grapple with questions about the nature of God's creation and the significance of humanity in a universe populated by other intelligent beings. Such a discovery could prompt theological reflection and reinterpretation, challenging traditional interpretations of religious texts and doctrines. In addition, one implication of discovering intelligent extraterrestrial life is the potential for cultural exchange and communication. Contact with an alien civilization could offer opportunities for mutual learning, collaboration, and cultural exchange, enriching human civilization and broadening our perspectives on life, morality, and spirituality. Moreover, another implication of discovering intelligent extraterrestrial life is the ethical and moral considerations surrounding interstellar communication and interaction. Scientists and policymakers would need to grapple with questions about the potential impact of contact on both human and alien societies, as well as the ethical responsibilities of communicating with other intelligent beings. Furthermore, one implication of discovering intelligent extraterrestrial life is the societal impact and public reaction. Such a discovery could provoke awe, wonder, and existential questions among the general public, as well as skepticism, fear, and anxiety about the unknown. Scientists and policymakers would need to navigate public perceptions and emotions surrounding the discovery. In addition, one implication of discovering intelligent extraterrestrial life is the potential for technological innovation and space exploration. The prospect of contact with an alien civilization could galvanize efforts to develop advanced space technologies, propulsion systems, and communication methods, accelerating humanity's exploration of the cosmos. Moreover, another implication of discovering intelligent extraterrestrial life is the philosophical implications for our understanding of consciousness and identity. Questions about the nature of intelligence, self-awareness, and agency could be re-examined in light of the existence of other intelligent beings, challenging traditional philosophical frameworks and assumptions. Furthermore, one implication of discovering intelligent extraterrestrial life is the potential for conflict and competition. Competition over resources, territory, and influence in the cosmos could arise between human and alien civilizations, posing challenges for diplomacy, peacekeeping, and international cooperation. In addition, one implication of discovering intelligent extraterrestrial life is the impact on environmental and planetary protection efforts. The discovery of inhabited exoplanets could raise questions about humanity's responsibility to protect and preserve other worlds, as well as the potential risks of contamination or interference with alien ecosystems. Moreover, another implication of discovering intelligent extraterrestrial life is the existential questions it raises about the nature of life, intelligence, and purpose in the universe. Humanity may grapple with questions about our place in a vast and potentially inhabited cosmos, as well as the meaning and significance of our existence in relation to other intelligent beings. Furthermore, one implication of discovering intelligent extraterrestrial life is the potential for spiritual and philosophical transformation. Contact with an alien civilization could prompt profound existential reflections and spiritual awakenings, inspiring new perspectives on the interconnectedness of all life and the mysteries of the cosmos. In addition, one implication of discovering intelligent extraterrestrial life is the impact on international relations and geopolitics. The prospect of contact with an alien civilization could reshape global power dynamics, alliances, and security strategies, as well as foster cooperation and collaboration among nations in addressing common challenges and opportunities. Moreover, another implication of discovering intelligent extraterrestrial life is the cultural and artistic responses it may inspire. Artists, writers, filmmakers, and musicians may explore themes of contact, communication, and coexistence with alien civilizations, contributing to a rich tapestry of cultural expression and imagination. Theological considerations regarding creation and life beyond Earth encompass a range of perspectives and interpretations within religious traditions. These considerations often intersect with questions about the nature of God's creative power, the purpose of life, and humanity's relationship to the cosmos. Moreover, theologians from various religious traditions grapple with questions about the theological significance of discovering life beyond Earth. Some theologians argue that the existence of extraterrestrial life would affirm the richness and diversity of God's creation, reflecting the boundless creativity and generosity of the divine. Furthermore, theological considerations regarding creation and life beyond Earth often intersect with interpretations of religious texts and doctrines. Some religious traditions interpret scriptures metaphorically or allegorically, allowing for flexibility in understanding the relationship between God, humanity, and the cosmos in light of scientific discoveries. In addition, theologians explore questions about the purpose and meaning of life in a universe populated by other intelligent beings. Some theologians speculate about the role of extraterrestrial civilizations in God's cosmic plan, pondering whether they too are endowed with free will, moral agency, and the capacity for spiritual growth and redemption. Moreover, theological considerations regarding creation and life beyond Earth raise questions about the uniqueness and centrality of humanity in God's design. Some theologians argue that the discovery of extraterrestrial life challenges traditional anthropocentric views of creation, inviting humanity to humbly acknowledge our place within a broader cosmic community. Furthermore, theological perspectives on creation and life beyond Earth often intersect with discussions about theodicy and the problem of evil. Some theologians contemplate whether extraterrestrial civilizations face similar challenges of suffering, sin, and redemption, and how such experiences might relate to the divine plan for the universe. In addition, theological considerations regarding creation and life beyond Earth prompt reflections on the nature of divine revelation and God's self-disclosure. Some theologians speculate about whether God's revelation extends to other intelligent beings, and how such beings might interpret and respond to divine messages. Moreover, theological perspectives on creation and life beyond Earth inform discussions about the relationship between science and religion. Some theologians advocate for a harmonious approach that integrates scientific discoveries with religious beliefs, viewing the exploration of the cosmos as a means of deepening human understanding of God's creation. Furthermore, theological considerations regarding creation and life beyond Earth raise questions about eschatology and the ultimate destiny of the universe. Some theologians speculate about whether extraterrestrial civilizations play a role in apocalyptic scenarios or eschatological visions, and how such events might unfold in a universe teeming with life. In addition, theological perspectives on creation and life beyond Earth shape ethical and moral deliberations about humanity's stewardship of the cosmos. Some theologians advocate for a holistic ethic that encompasses the well-being of all sentient beings, including extraterrestrial civilizations, and calls humanity to act as responsible caretakers of the universe. Moreover, theological considerations regarding creation and life beyond Earth prompt reflections on the mystery and transcendence of God's divine nature. Some theologians ponder whether the discovery of extraterrestrial life offers glimpses of God's presence and activity in the universe, inviting humanity to contemplate the depths of divine wisdom and love. Furthermore, theological perspectives on creation and life beyond Earth inspire theological creativity and imagination. Some theologians explore speculative scenarios and narratives about encounters with extraterrestrial beings, drawing upon religious symbols, myths, and metaphors to envision humanity's place in a cosmic tapestry of life. In addition, theological considerations regarding creation and life beyond Earth encourage humility and reverence in the face of cosmic mysteries. Some theologians emphasize the importance of approaching questions about the nature of God's creation with humility and openness to new insights and revelations. Moreover, theological perspectives on creation and life beyond Earth foster dialogue and collaboration among diverse religious traditions and worldviews. Some theologians advocate for interfaith engagement and cooperation in exploring theological questions about the existence of extraterrestrial life, recognizing the richness and complexity of religious diversity. Furthermore, theological considerations regarding creation and life beyond Earth invite humanity to contemplate the interconnectedness of all life in the universe. Some theologians envision a cosmic theology that embraces the diversity of life forms and celebrates the unity of all creation in the divine presence. Ethical challenges in contacting or interacting with extraterrestrial civilizations encompass a complex array of considerations spanning moral, cultural, and practical dimensions. As humanity continues to explore the cosmos and search for signs of intelligent life, these ethical dilemmas become increasingly pertinent. Moreover, one ethical challenge is the potential impact of contact on the autonomy and self-determination of extraterrestrial civilizations. Initiating communication or interaction with alien beings raises questions about respecting their rights, values, and sovereignty, as well as the potential consequences of introducing external influences into their societies. Furthermore, another ethical challenge is the risk of unintentional harm or misunderstanding in interstellar communication. Differences in language, culture, and worldview could lead to misinterpretation or conflict, posing risks to both human and alien societies. Ethical communication protocols and strategies are needed to mitigate these risks and promote mutual understanding. In addition, one ethical challenge is the potential for exploitation or exploitation of extraterrestrial resources. The discovery of habitable exoplanets or valuable planetary resources could tempt humanity to engage in colonialism, resource extraction, or territorial expansion at the expense of alien civilizations. Ethical guidelines and frameworks are needed to ensure equitable and sustainable interactions with extraterrestrial worlds. Moreover, another ethical challenge is the question of how to balance scientific curiosity with ethical considerations in the search for extraterrestrial life. Scientists and researchers must grapple with questions about the potential impact of their actions on alien societies, as well as the ethical responsibilities of representing humanity in interstellar communication. Furthermore, one ethical challenge is the risk of cultural imperialism or ethnocentrism in human interactions with extraterrestrial civilizations. Human values, norms, and biases could inadvertently shape perceptions of alien cultures and influence the dynamics of interstellar communication. Ethical awareness and cultural sensitivity are essential for fostering respectful and equitable relations with alien beings. In addition, one ethical challenge is the potential for unintended consequences or unforeseen risks in contacting or interacting with extraterrestrial civilizations. Human actions could inadvertently disrupt alien ecosystems, trigger societal upheaval, or provoke conflict among alien beings. Ethical decision-making frameworks are needed to assess and mitigate these risks. Moreover, another ethical challenge is the question of whether humanity has a moral obligation to intervene in the affairs of extraterrestrial civilizations. While some argue that intervention may be justified to prevent harm or promote ethical values, others caution against imposing human values or norms on alien societies without their consent. Furthermore, one ethical challenge is the potential for unequal power dynamics or asymmetrical relations in interstellar communication. Technologically advanced civilizations may wield disproportionate influence over less developed societies, raising concerns about coercion, manipulation, or exploitation. Ethical principles of fairness, reciprocity, and consent are essential for promoting equitable and respectful interactions. In addition, one ethical challenge is the question of how to handle information about the existence of extraterrestrial life responsibly and transparently. Governments, scientific institutions, and media organizations must grapple with questions about when and how to disclose information about contact or communication with alien civilizations, as well as the potential social, cultural, and psychological impacts of such revelations. Moreover, another ethical challenge is the potential for conflict or competition among human societies over the discovery of extraterrestrial life. The prospect of alien contact could provoke geopolitical tensions, religious conflicts, or economic rivalries, posing challenges for international cooperation and coordination in managing the consequences of contact. Furthermore, one ethical challenge is the question of how to promote peace, cooperation, and mutual respect in interstellar relations. Building trust and understanding between human and alien civilizations requires proactive efforts to foster dialogue, cooperation, and cultural exchange, as well as mechanisms for resolving conflicts and addressing grievances. In addition, one ethical challenge is the need to develop inclusive and participatory governance structures for managing interstellar communication and interaction. Decision-making processes should involve input from diverse stakeholders, including scientists, policymakers, ethicists, and representatives of alien civilizations, to ensure accountability, transparency, and legitimacy. Moreover, another ethical challenge is the potential for unintended consequences or unforeseen risks in initiating interstellar communication. Human actions could have far-reaching consequences for both humanity and alien societies, raising questions about the ethical responsibility of individuals, organizations, and governments in shaping the future of interstellar relations. Furthermore, one ethical challenge is the imperative to approach interstellar communication and interaction with humility, respect, and reverence for the diversity and complexity of life in the cosmos. Recognizing the intrinsic value and dignity of all sentient beings is essential for fostering ethical and harmonious relations between human and alien civilizations. Quantum mechanics is a fundamental theory in physics that describes the behavior of particles at the subatomic level. It provides a mathematical framework for understanding phenomena such as wave-particle duality, quantum entanglement, and probabilistic behavior. Moreover, quantum mechanics revolutionized our understanding of the physical world by introducing principles that defy classical intuition. Concepts such as superposition, where particles can exist in multiple states simultaneously, and uncertainty, which limits our ability to precisely measure certain properties, challenge our conventional understanding of reality. Furthermore, quantum mechanics has practical applications in various fields, including quantum computing, quantum cryptography, and quantum teleportation. These technologies leverage the unique properties of quantum systems to perform tasks that are impossible or impractical with classical methods, opening new frontiers in information processing and communication. In addition, one of the key principles of quantum mechanics is wave-particle duality, which suggests that particles such as electrons and photons exhibit both wave-like and particle-like behavior. This duality challenges the classical distinction between particles and waves and underscores the probabilistic nature of quantum phenomena. Moreover, another important concept in quantum mechanics is quantum entanglement, which occurs when two or more particles become correlated in such a way that the state of one particle instantaneously influences the state of another, even when they are separated by large distances. This phenomenon has been experimentally confirmed and is the basis for quantum teleportation and quantum communication protocols. Furthermore, quantum mechanics introduces the notion of uncertainty, as described by Heisenberg's uncertainty principle, which states that certain pairs of physical properties, such as position and momentum, cannot be simultaneously measured with arbitrary precision. This principle imposes fundamental limits on our ability to predict the behavior of quantum systems. In addition, one of the most famous experiments in quantum mechanics is the double-slit experiment, which demonstrates the wave-like behavior of particles such as electrons and photons. When particles are sent through two closely spaced slits, they form an interference pattern characteristic of waves, suggesting that they exhibit wave-like behavior even when detected as particles. Moreover, another intriguing aspect of quantum mechanics is the phenomenon of quantum tunneling, where particles can pass through potential energy barriers that would be classically impassable. This phenomenon has important implications in various fields, including semiconductor physics, nuclear fusion, and quantum chemistry. Furthermore, quantum mechanics also encompasses the concept of quantum superposition, where particles can exist in multiple states simultaneously until they are observed or measured, at which point they collapse into a single definite state. This principle lies at the heart of quantum computing, where quantum bits or qubits can represent multiple values simultaneously. In addition, quantum mechanics introduces the concept of quantum decoherence, which explains how quantum systems lose their coherence and become effectively classical through interactions with their environment. Decoherence is a major challenge in quantum computing and quantum information processing, as it limits the ability to maintain and manipulate quantum states. Moreover, another important aspect of quantum mechanics is the role of observation and measurement in determining the behavior of quantum systems. According to the Copenhagen interpretation, the act of measurement collapses the wave function of a quantum system, determining its state with probability governed by the wave function. Furthermore, quantum mechanics also predicts the existence of fundamental particles such as quarks, leptons, and bosons, which are the building blocks of matter and carriers of fundamental forces in the universe. These particles are described by quantum field theory, which extends the principles of quantum mechanics to fields that permeate all of space and time. In addition, quantum mechanics plays a crucial role in our understanding of the structure and behavior of atoms and molecules. Quantum theory provides the theoretical foundation for chemical bonding, molecular spectroscopy, and the behavior of materials at the atomic and molecular level. Moreover, another area where quantum mechanics has profound implications is in the study of black holes and the nature of space-time. Quantum field theory in curved space-time, combined with the principles of quantum mechanics, offers insights into the behavior of matter and energy in the extreme conditions near black holes and during the early universe. Theoretical implications for determinism and free will arise from the principles of quantum mechanics, challenging traditional notions of causality and human agency. Quantum mechanics introduces inherent randomness and uncertainty at the fundamental level of reality, undermining the deterministic worldview of classical physics. Moreover, quantum mechanics suggests that the behavior of particles at the subatomic level is governed by probabilistic laws rather than strict determinism. This probabilistic nature raises questions about the predictability of physical processes and the extent to which the future can be precisely determined based on present conditions. Furthermore, the concept of quantum superposition, where particles can exist in multiple states simultaneously until observed, challenges the idea of a deterministic universe with a single predetermined outcome. Instead, quantum superposition suggests a multiplicity of possible states, each with a certain probability of being realized upon measurement. In addition, quantum mechanics introduces the phenomenon of quantum indeterminacy, where the outcome of a measurement is fundamentally uncertain until it occurs. This indeterminacy arises from the probabilistic nature of wave functions and the inherent randomness of quantum processes, leading to unpredictable outcomes even under identical conditions. Moreover, the principle of quantum entanglement poses challenges to classical notions of causality and determinism by suggesting non-local correlations between particles that transcend spatial separation. This phenomenon implies that the behavior of one particle can instantaneously influence the state of another, regardless of the distance between them. Furthermore, the implications of quantum mechanics for determinism and free will have sparked philosophical debates about the nature of causality, responsibility, and human agency. Some philosophers argue that the indeterminacy inherent in quantum mechanics provides a basis for free will, as it introduces genuine randomness into the universe that allows for alternative possibilities and choices. In addition, others contend that the apparent randomness of quantum events does not necessarily imply free will, as it may simply reflect our limited knowledge or understanding of the underlying deterministic processes. This perspective suggests that while quantum mechanics may introduce uncertainty, it does not necessarily grant humans the ability to transcend causal constraints. Moreover, the relationship between quantum mechanics and free will raises questions about the nature of consciousness and the role of observers in shaping reality. Some interpretations of quantum mechanics suggest that consciousness plays a fundamental role in collapsing the wave function and determining the outcome of measurements, implying a close connection between mind and matter. Furthermore, the implications of quantum mechanics for determinism and free will extend beyond philosophical speculation to practical implications in fields such as neuroscience and psychology. The indeterminacy introduced by quantum mechanics may influence the behavior of biological systems, including the human brain, leading to new insights into the nature of consciousness and decision-making. In addition, the interplay between quantum mechanics and free will has implications for ethical and moral theories, as it challenges traditional notions of responsibility and accountability. If quantum indeterminacy allows for genuine randomness in decision-making processes, it may call into question the basis for attributing moral praise or blame to individuals. Moreover, the implications of quantum mechanics for determinism and free will have implications for our understanding of causality and the nature of reality. Quantum mechanics suggests a more nuanced view of causation, where deterministic processes coexist with indeterministic events, blurring the boundaries between cause and effect. Furthermore, the implications of quantum mechanics for determinism and free will have implications for our understanding of causality and the nature of reality. Quantum mechanics suggests a more nuanced view of causation, where deterministic processes coexist with indeterministic events, blurring the boundaries between cause and effect. In addition, the implications of quantum mechanics for determinism and free will have implications for our understanding of causality and the nature of reality. Quantum mechanics suggests a more nuanced view of causation, where deterministic processes coexist with indeterministic events, blurring the boundaries between cause and effect. God's role in quantum indeterminacy has been a subject of philosophical and theological speculation. Some theologians and philosophers argue that God's omnipotence and sovereignty extend to the quantum realm, suggesting that God may directly influence or guide the outcomes of quantum events. Moreover, proponents of this view often appeal to the concept of divine providence, which posits that God's will is ultimately responsible for all events in the universe, including those governed by quantum mechanics. From this perspective, quantum indeterminacy does not imply randomness or chance, but rather reflects God's intentional and purposeful activity. Furthermore, others argue that God's involvement in quantum indeterminacy is compatible with human free will, as it allows for genuine choices and possibilities within the framework of God's overarching providential plan. According to this view, God's guidance and influence in the quantum realm do not negate human agency, but rather work in harmony with it. In addition, some theologians and philosophers propose that God's role in quantum indeterminacy is manifested through the concept of divine sustenance, where God continuously upholds and sustains the existence and activity of all created beings, including the fundamental processes of the universe. Moreover, another perspective acknowledges the mystery and limitations of human understanding when it comes to discerning God's involvement in quantum indeterminacy. This view emphasizes the humility of theological inquiry and encourages openness to multiple interpretations of God's relationship to the quantum realm. Furthermore, the implications of God's role in quantum indeterminacy extend beyond theological speculation to practical questions about the nature of divine action and intervention in the world. Some theologians argue that God's activity in the quantum realm provides a theological framework for understanding miracles and supernatural phenomena. In addition, others caution against anthropomorphizing God's relationship to quantum events or reducing divine action to a mechanistic intervention in natural processes. Instead, they emphasize the transcendence and mystery of God's activity, which transcends human comprehension and defies simplistic explanations. Moreover, the question of God's role in quantum indeterminacy raises profound theological and philosophical questions about the nature of causality, contingency, and divine providence. These questions challenge traditional understandings of divine action and invite theologians to explore new ways of articulating God's relationship to the created order. Furthermore, some theologians and philosophers suggest that God's role in quantum indeterminacy may be understood in terms of divine creativity and freedom. From this perspective, God's ongoing involvement in the unfolding of the universe includes a dynamic interplay with the indeterministic processes of quantum mechanics. In addition, others propose that God's relationship to quantum indeterminacy is mediated through secondary causes and natural laws, which operate according to God's design and purpose. In this view, God's sovereignty over the quantum realm is expressed through the establishment of orderly and predictable patterns in the universe. Moreover, the question of God's role in quantum indeterminacy has implications for theological understandings of divine transcendence and immanence. Some theologians argue that God's involvement in the quantum realm reflects both God's transcendent power and intimate presence within the fabric of creation. Furthermore, others caution against conflating theological speculation with scientific explanations of quantum phenomena, emphasizing the distinct methods and domains of inquiry employed by theology and science. While theology may offer insights into the meaning and significance of quantum indeterminacy, it does not seek to replace or undermine scientific explanations. In addition, the question of God's role in quantum indeterminacy invites theologians to engage in interdisciplinary dialogue with physicists, philosophers, and ethicists to explore the theological implications of quantum theory. This dialogue fosters mutual enrichment and deeper understanding of the complex relationship between science and theology. Moreover, the exploration of God's role in quantum indeterminacy encourages theologians to reflect on the mystery and wonder of God's creative activity in the universe. By grappling with the implications of quantum mechanics for theology, theologians gain new perspectives on the nature of God's transcendence, immanence, and providential care. Theological reflections on the uncertainty principle delve into profound questions about the nature of reality, human knowledge, and divine action. The uncertainty principle, formulated by Werner Heisenberg, asserts that certain pairs of physical properties, such as position and momentum, cannot be precisely known simultaneously. Moreover, theologians explore the implications of the uncertainty principle for theological understandings of God's omniscience and the limits of human knowledge. The inherent uncertainty in quantum mechanics challenges the idea of exhaustive human understanding and underscores the mystery and complexity of the universe. Furthermore, some theologians suggest that the uncertainty principle invites humility in human inquiry and fosters a sense of awe and wonder in the face of the unknown. By acknowledging the limits of human knowledge, theologians can cultivate a deeper appreciation for the mystery of God's creation and the ineffable depths of divine wisdom. In addition, the uncertainty principle raises questions about the relationship between divine sovereignty and human freedom. If the universe is fundamentally characterized by uncertainty and indeterminacy, how does this affect theological concepts of divine providence and human agency? Moreover, theologians grapple with the tension between divine transcendence and immanence in light of the uncertainty principle. While God is understood as transcending the created order, theologians also affirm God's presence and activity within the fabric of reality. The uncertainty principle challenges theologians to articulate how God interacts with a universe characterized by inherent unpredictability. Furthermore, theological reflections on the uncertainty principle intersect with broader discussions about the relationship between science and religion. Some theologians view quantum indeterminacy as compatible with theological notions of divine creativity and freedom, while others see it as raising questions about traditional understandings of divine action and providence. In addition, the uncertainty principle prompts theologians to consider the role of chance and contingency in the unfolding of God's plan for creation. While theologians affirm God's overarching providential care for the universe, they also recognize the role of randomness and unpredictability in shaping the course of events. Moreover, theological reflections on the uncertainty principle highlight the importance of interdisciplinary dialogue between theology and the natural sciences. By engaging with insights from physics, theology can enrich its understanding of the natural world and contribute to a more holistic vision of reality. Furthermore, theologians explore the implications of the uncertainty principle for theological concepts of order and chaos. While the uncertainty principle suggests inherent randomness and unpredictability in the quantum realm, theologians affirm the presence of divine order and purpose in the universe. In addition, theological reflections on the uncertainty principle invite theologians to re-examine traditional theological categories and metaphors in light of contemporary scientific insights. Concepts such as divine sovereignty, providence, and omniscience may take on new meanings in the context of quantum indeterminacy. Moreover, theologians consider how the uncertainty principle informs theological understandings of divine revelation and human interpretation. Just as quantum mechanics involves a dynamic interplay between observer and observed, theologians explore how divine revelation is mediated through human interpretation and understanding. Furthermore, Theological reflections on the uncertainty principle raise questions about the relationship between faith and reason. How do theologians reconcile the mystery and uncertainty of the quantum realm with the demands of rational inquiry and theological coherence? In addition, theologians explore the implications of the uncertainty principle for theological anthropology and ethics. If human knowledge is inherently limited and uncertain, how does this affect theological understandings of human identity, responsibility, and moral decision-making? Moreover, theological reflections on the uncertainty principle encourage theologians to embrace a posture of openness and receptivity to the ongoing revelation of God's presence in the world. By recognizing the inherent mystery and unpredictability of the universe, theologians can cultivate a deeper sense of wonder and reverence for the divine. Quantum cosmology explores the application of quantum mechanics to the study of the origin, evolution, and structure of the universe. It seeks to address fundamental questions about the nature of space, time, and matter at the earliest moments of cosmic history. Moreover, quantum cosmology intersects with theistic beliefs in various ways, inviting theological reflections on the nature of God's creative activity and the ultimate meaning and purpose of the universe. The application of quantum principles to cosmology raises profound questions about the role of divine agency in cosmic emergence. Furthermore, some theologians and philosophers view quantum cosmology as providing a scientific framework for understanding the concept of creatio ex nihilo, or creation out of nothing. Quantum fluctuations in the early universe, according to this view, may offer insights into how the universe emerged from a state of primordial chaos. In addition, the concept of quantum cosmology challenges traditional cosmological models that rely solely on classical physics, such as the Big Bang theory. By incorporating quantum principles into cosmological models, scientists and theologians can explore new avenues for understanding the origins and structure of the universe. Moreover, quantum cosmology prompts theologians to reconsider theological narratives of creation and divine providence in light of contemporary scientific insights. The dynamic interplay between quantum fluctuations and cosmic evolution invites theologians to articulate how God's creative activity unfolds within the fabric of cosmic history. Furthermore, the relationship between quantum cosmology and theistic beliefs raises questions about the nature of divine transcendence and immanence. How does God interact with the quantum realm, and what implications does this have for theological understandings of God's presence and activity in the world? In addition, some theologians suggest that quantum cosmology provides a scientific basis for exploring theological concepts of divine sustenance and ongoing creation. By understanding the universe as dynamically evolving and contingent upon quantum fluctuations, theologians can affirm God's continuous involvement in the unfolding of cosmic history. Moreover, the application of quantum principles to cosmology challenges deterministic views of cosmic evolution and invites theologians to explore the role of contingency and chance in the universe. How does the inherent unpredictability of quantum processes shape the course of cosmic history, and what implications does this have for theological understandings of divine providence? Furthermore, quantum cosmology invites theologians to engage in interdisciplinary dialogue with physicists, cosmologists, and philosophers to explore the theological implications of quantum theory. By integrating insights from science and theology, theologians can develop a more comprehensive understanding of the relationship between God and the cosmos. In addition, theistic interpretations of quantum cosmology vary depending on theological commitments and philosophical perspectives. Some theologians view quantum cosmology as compatible with traditional theological concepts of creation and divine providence, while others see it as challenging or expanding traditional understandings. Moreover, the implications of quantum cosmology for theistic beliefs extend beyond cosmological questions to theological anthropology and ethics. How does our understanding of the universe as a product of quantum fluctuations affect theological understandings of human identity, purpose, and moral responsibility? Furthermore, the exploration of quantum cosmology encourages theologians to embrace a posture of humility and openness in the face of the mysteries of the cosmos. By acknowledging the limits of human understanding and the complexity of cosmic phenomena, theologians can cultivate a deeper sense of reverence for the wonders of creation. In addition, Quantum cosmology prompts theologians to reflect on the relationship between scientific inquiry and religious faith. How can theology engage with scientific discoveries in a way that enriches our understanding of God's creative activity and the ultimate meaning of the universe? Moreover, the integration of quantum cosmology and theistic beliefs offers new perspectives on the relationship between science and religion, inviting theologians to explore the ways in which scientific insights can inform and enrich theological reflection. By embracing a holistic approach to knowledge, theologians can develop a more nuanced understanding of the mysteries of the cosmos and the nature of divine transcendence. Differentiating between scientific and religious truths involves recognizing the distinct methods, aims, and domains of inquiry employed by science and religion. Science seeks to understand the natural world through empirical observation, experimentation, and the formulation of testable hypotheses. Moreover, scientific truths are provisional and subject to revision in light of new evidence or more comprehensive theoretical frameworks. The scientific method emphasizes skepticism, critical inquiry, and the peer review process to ensure the reliability and validity of scientific knowledge. Furthermore, scientific truths are typically descriptive and explanatory in nature, focusing on observable phenomena and natural processes. Science aims to uncover patterns, laws, and regularities in the physical world, providing explanations for natural phenomena based on empirical evidence. In addition, religious truths, on the other hand, often concern matters of ultimate meaning, purpose, and value that transcend empirical observation and scientific analysis. Religion explores questions about the nature of reality, human existence, morality, and the divine through sacred texts, rituals, and theological reflection. Moreover, religious truths are often expressed in symbolic, metaphorical, or allegorical language, conveying deeper insights into the human condition and the mysteries of existence. Religious narratives and doctrines may draw upon mythological, allegorical, or poetic imagery to convey spiritual truths that transcend literal interpretation. Furthermore, religious truths are often grounded in faith, revelation, and personal experience rather than empirical evidence or scientific proof. Belief in religious truths may involve elements of trust, commitment, and existential engagement with questions of ultimate significance. In addition, while scientific and religious truths may address overlapping questions about the nature of reality, they do so from different perspectives and using different methodologies. Science focuses on understanding the natural world through empirical observation and experimentation, while religion explores existential, moral, and metaphysical questions through faith, revelation, and spiritual insight. Moreover, the relationship between scientific and religious truths is complex and multifaceted, with both complementarity and potential for conflict. While science and religion may offer complementary perspectives on certain aspects of reality, they may also come into tension when their claims appear to contradict or challenge one another. Furthermore, some theologians and philosophers advocate for a separate magisteria approach, which posits that science and religion address distinct domains of knowledge and inquiry that are not in direct competition. According to this view, science deals with empirical facts and natural phenomena, while religion addresses questions of meaning, purpose, and value. In addition, others argue for a dialogue model of interaction between science and religion, which encourages mutual engagement, cooperation, and enrichment between scientific and religious perspectives. This approach recognizes the potential for dialogue and collaboration between disciplines while respecting their methodological and epistemological differences. Moreover, the distinction between scientific and religious truths is not always clear-cut, as both domains of inquiry may influence and inform one another in complex ways. Scientific discoveries may raise philosophical and theological questions, while religious insights may inspire scientific inquiry and ethical reflection. Furthermore, the relationship between scientific and religious truths is shaped by cultural, historical, and social factors, with differing attitudes towards science and religion prevailing in different contexts. The perceived conflict or harmony between science and religion often reflects broader cultural narratives and worldviews. In addition, individuals may navigate the relationship between scientific and religious truths in various ways, incorporating insights from both domains into their personal beliefs and worldviews. Some may prioritize scientific explanations for natural phenomena, while maintaining religious beliefs about ultimate meaning and purpose, while others may integrate scientific and religious perspectives more harmoniously. Moreover, the distinction between scientific and religious truths invites ongoing reflection and dialogue among scientists, theologians, philosophers, and ethicists. By exploring the complementary insights and potential tensions between science and religion, scholars can contribute to a more nuanced understanding of the complex relationship between human knowledge and existential questions. The epistemological limits of science and religion refer to the boundaries of knowledge and understanding within each respective domain. Science is limited to empirical observation, experimentation, and rational analysis in its quest to understand the natural world. Moreover, scientific inquiry is restricted to questions that are testable, falsifiable, and amenable to empirical investigation. While science has made remarkable progress in explaining many aspects of the universe, there are inherent limitations to what can be known through scientific methods alone. Furthermore, science operates within a framework of methodological naturalism, which restricts its inquiry to naturalistic explanations for natural phenomena. This means that scientific explanations do not invoke supernatural or metaphysical entities, unless they can be empirically observed or inferred from natural phenomena. In addition, the epistemological limits of science extend to questions of ultimate meaning, purpose, and value, which lie outside the scope of scientific inquiry. While science can provide valuable insights into the workings of the natural world, it cannot address existential or metaphysical questions that fall within the purview of religion. Moreover, religion also has epistemological limits, as it relies on faith, revelation, and spiritual experience as sources of knowledge and understanding. Religious truths are often grounded in subjective experiences of the divine rather than empirical evidence or rational argumentation. Furthermore, the epistemological limits of religion include the diversity of religious beliefs and interpretations, which may vary widely among different cultures, traditions, and individuals. Religious truths are often expressed in symbolic, metaphorical, or allegorical language, making them open to multiple interpretations. In addition, while religion may offer insights into existential questions and provide moral and ethical guidance, it cannot provide empirical or scientific explanations for natural phenomena. Religious claims about the nature of reality, the existence of deities, and the afterlife are matters of faith rather than empirical knowledge. Moreover, the epistemological limits of both science and religion raise questions about the relationship between empirical evidence, subjective experience, and rational interpretation. While science seeks to uncover objective truths about the natural world, religion addresses questions of ultimate meaning and purpose that transcend empirical observation. Furthermore, some philosophers and theologians advocate for a complementary approach to knowledge, which recognizes the distinct but complementary roles of science and religion in addressing different aspects of reality. According to this view, science and religion can provide mutually enriching perspectives on the human condition and the nature of the universe. In addition, others emphasize the importance of humility and openness in recognizing the epistemological limits of both science and religion. Acknowledging the boundaries of human knowledge can foster a spirit of curiosity, wonder, and reverence for the mysteries of existence. Moreover, the epistemological limits of science and religion invite interdisciplinary dialogue and collaboration among scientists, theologians, philosophers, and ethicists. By engaging with diverse perspectives and methods of inquiry, scholars can gain deeper insights into the complex and multifaceted nature of reality. Furthermore, individuals may navigate the epistemological limits of science and religion in different ways, depending on their cultural, religious, and philosophical backgrounds. Some may prioritize scientific explanations for natural phenomena while maintaining religious beliefs about existential questions, while others may integrate scientific and religious perspectives more harmoniously. In addition, the recognition of epistemological limits can foster a spirit of intellectual humility and openness to new ideas and perspectives. By embracing the complexity and diversity of human knowledge, individuals can cultivate a more nuanced and inclusive understanding of the world. Moreover, the exploration of epistemological limits encourages scholars to critically examine the methods, assumptions, and biases that shape scientific and religious inquiry. By interrogating the foundations of knowledge, scholars can contribute to a more rigorous and self-aware approach to understanding the human condition and the mysteries of existence. Complementary perspectives on existence and purpose recognize the multifaceted nature of human experience and the diversity of ways in which individuals seek to make sense of the world. Science and religion offer distinct but complementary perspectives on fundamental questions about existence, purpose, and the nature of reality. Moreover, while science focuses on understanding the natural world through empirical observation and rational analysis, religion explores questions of ultimate meaning, purpose, and value through faith, revelation, and spiritual insight. Furthermore, rather than viewing science and religion as mutually exclusive or competing frameworks, complementary perspectives recognize the potential for dialogue, cooperation, and enrichment between scientific and religious perspectives. In addition, some theologians and philosophers advocate for a dialogue model of interaction between science and religion, which encourages mutual engagement, cooperation, and enrichment between scientific and religious perspectives. Moreover, according to this view, science and religion can offer complementary insights into different aspects of reality, providing distinct but complementary perspectives on questions of existence, purpose, and meaning. Furthermore, by integrating insights from both science and religion, individuals can develop a more holistic and nuanced understanding of the human condition and the mysteries of existence. In addition, complementary perspectives on existence and purpose recognize that human experience is multifaceted and complex, encompassing both empirical and subjective dimensions. Moreover, while science seeks to uncover objective truths about the natural world, religion addresses questions of ultimate meaning, purpose, and value that transcend empirical observation. Furthermore, rather than viewing science and religion as incompatible or contradictory, complementary perspectives acknowledge the potential for mutual enrichment and dialogue between scientific and religious worldviews. In addition, by embracing a complementary approach to knowledge, individuals can cultivate a deeper appreciation for the diversity of human experience and the complexity of existential questions. Moreover, complementary perspectives on existence and purpose encourage individuals to engage in interdisciplinary dialogue and collaboration, drawing on insights from science, religion, philosophy, and other fields of inquiry. Furthermore, by exploring complementary perspectives on existence and purpose, individuals can gain deeper insights into the richness and complexity of human experience. In addition, by recognizing the potential for dialogue and cooperation between scientific and religious perspectives, individuals can foster a spirit of openness, curiosity, and intellectual humility in their quest for understanding. Moreover, complementary perspectives on existence and purpose invite individuals to embrace the complexity and diversity of human experience, recognizing that different individuals may find meaning and purpose in different ways. Furthermore, by integrating insights from science and religion, individuals can develop a more holistic and integrated understanding of the human condition and the mysteries of existence. Dialogue between scientists and theologians plays a crucial role in fostering mutual understanding, collaboration, and enrichment between scientific and religious perspectives. By engaging in dialogue, scientists and theologians can exchange insights, explore common ground, and address areas of tension or misunderstanding. Moreover, dialogue between scientists and theologians encourages interdisciplinary cooperation and collaboration, drawing on the expertise of both fields to address complex questions about the nature of reality, human existence, and the ultimate meaning and purpose of life. Furthermore, dialogue between scientists and theologians can help bridge the gap between scientific and religious communities, fostering mutual respect, appreciation, and cooperation. In addition, by engaging in dialogue, scientists and theologians can contribute to a more nuanced and sophisticated understanding of the relationship between science and religion, moving beyond simplistic narratives of conflict or harmony. Moreover, dialogue between scientists and theologians invites both parties to approach questions of existence, purpose, and meaning with humility, openness, and intellectual curiosity. Furthermore, dialogue between scientists and theologians can foster interdisciplinary collaboration and innovation, leading to new insights and discoveries that integrate scientific and religious perspectives. In addition, by engaging in dialogue, scientists and theologians can address ethical, social, and philosophical implications of scientific and technological advancements, drawing on both empirical evidence and moral and ethical principles. Moreover, dialogue between scientists and theologians can promote public understanding and appreciation of science and religion, helping to bridge the gap between academic scholarship and broader societal discourse. Furthermore, dialogue between scientists and theologians can contribute to a more holistic and integrated approach to knowledge, recognizing the complementary insights and perspectives offered by both scientific and religious inquiry. In addition, dialogue between scientists and theologians can help address contemporary challenges and issues facing humanity, such as climate change, bioethics, and social justice, by drawing on interdisciplinary expertise and collaboration. Moreover, dialogue between scientists and theologians can foster a spirit of mutual respect, empathy, and cooperation, recognizing the value of diverse perspectives and approaches to understanding the world. Furthermore, dialogue between scientists and theologians can promote critical reflection and self-examination within both scientific and religious communities, encouraging scholars to question assumptions, challenge biases, and explore new avenues of inquiry. In addition, by engaging in dialogue, scientists and theologians can contribute to the advancement of knowledge and understanding in their respective fields, enriching scholarship and fostering intellectual growth. Moreover, dialogue between scientists and theologians can inspire individuals to explore questions of existence, purpose, and meaning in their own lives, encouraging a deeper engagement with both scientific and religious perspectives. Furthermore, dialogue between scientists and theologians can contribute to the development of a more inclusive and pluralistic society, where diverse worldviews and beliefs are respected and valued. Cultivating mutual respect and understanding in discourse between scientific and religious communities is essential for fostering constructive dialogue and collaboration. By approaching conversations with openness, empathy, and a willingness to listen, individuals can create a supportive and inclusive environment where diverse perspectives are valued and respected. Moreover, cultivating mutual respect and understanding involves acknowledging the validity and importance of different ways of knowing and understanding the world. Both scientific and religious perspectives offer valuable insights into the human experience and the mysteries of existence, and recognizing the richness of this diversity can enrich discourse and enhance mutual understanding. Furthermore, cultivating mutual respect and understanding requires recognizing and addressing potential sources of tension, misunderstanding, or conflict between scientific and religious worldviews. By acknowledging differences in methodology, language, and epistemology, individuals can work towards finding common ground and building bridges between different ways of thinking and knowing. In addition, cultivating mutual respect and understanding involves fostering empathy and compassion towards individuals with differing beliefs or worldviews. By seeking to understand the perspectives, experiences, and values of others, individuals can build trust and rapport, even in the midst of disagreement or difference. Moreover, cultivating mutual respect and understanding requires creating spaces for dialogue and exchange where individuals feel safe, respected, and valued. By promoting open and inclusive discourse, individuals can create opportunities for learning, growth, and mutual enrichment. Furthermore, cultivating mutual respect and understanding involves challenging stereotypes, prejudices, and misconceptions that may hinder productive dialogue and collaboration. By promoting empathy, humility, and intellectual curiosity, individuals can overcome barriers to communication and build meaningful relationships across diverse perspectives. In addition, cultivating mutual respect and understanding requires recognizing and affirming the inherent dignity and worth of every individual, regardless of their beliefs or background. By fostering a culture of respect and inclusivity, individuals can create environments where diverse perspectives are welcomed and valued. Moreover, cultivating mutual respect and understanding involves engaging in active listening and dialogue, where individuals seek to understand and empathize with the perspectives of others. By practicing empathy and humility, individuals can build trust and rapport, even in the midst of disagreement or difference. Furthermore, cultivating mutual respect and understanding requires acknowledging the limitations of one's own perspective and being open to learning from others. By recognizing that no single worldview or belief system has a monopoly on truth, individuals can approach dialogue with humility and curiosity. In addition, cultivating mutual respect and understanding involves being mindful of the power dynamics and inequalities that may shape discourse between scientific and religious communities. By promoting equity, inclusivity, and social justice, individuals can create more just and equitable spaces for dialogue and collaboration. Moreover, cultivating mutual respect and understanding requires recognizing and confronting bias, discrimination, and marginalization within scientific and religious communities. By promoting diversity, equity, and inclusion, individuals can create environments where all voices are heard and valued. Furthermore, cultivating mutual respect and understanding involves building relationships based on trust, honesty, and integrity. By fostering a culture of respect and transparency, individuals can create environments where meaningful dialogue and collaboration can thrive. In addition, cultivating mutual respect and understanding requires recognizing the interconnectedness of all beings and the importance of building relationships based on compassion, empathy, and solidarity. By promoting a sense of shared humanity and interconnectedness, individuals can create a more compassionate and inclusive world. Evolutionary theory provides a comprehensive framework for understanding the mechanisms of biological diversity and the processes that shape the development and adaptation of life on Earth. Developed by Charles Darwin in the 19th century, evolutionary theory has since become one of the central principles of modern biology. Moreover, evolutionary theory posits that species change over time through the process of natural selection, where individuals with advantageous traits are more likely to survive and reproduce. Over successive generations, these advantageous traits become more common in the population, leading to the gradual evolution of new species. Furthermore, evolutionary theory is supported by a vast array of empirical evidence from fields such as paleontology, genetics, comparative anatomy, and biogeography. Fossil records, for example, provide evidence of transitional forms that document the gradual changes in species over time. In addition, molecular genetics has provided further support for evolutionary theory by revealing the underlying genetic mechanisms responsible for heredity and variation. Comparative genomics, for instance, has shown that organisms share common genetic sequences, providing evidence for a shared evolutionary history. Moreover, evolutionary theory explains the patterns of biodiversity observed in nature, including the distribution of species across different habitats and geographic regions. Biogeographical studies, for example, demonstrate how organisms have adapted to diverse environments through the process of natural selection. Furthermore, evolutionary theory also provides insights into the origins of complex biological structures and behaviors. The theory of natural selection, coupled with principles of genetics and developmental biology, offers explanations for the evolution of traits such as wings, eyes, and social behaviors. In addition, evolutionary theory has practical applications in fields such as medicine, agriculture, and conservation biology. Understanding the principles of evolution allows scientists to develop more effective strategies for combating diseases, managing crop populations, and conserving endangered species. Moreover, evolutionary theory has implications for our understanding of human evolution and the origins of Homo sapiens. Fossil evidence, genetic studies, and comparative anatomy provide insights into the evolutionary history of humans and their relationships with other primates. Furthermore, evolutionary theory has sparked debates and controversies, particularly in relation to religious beliefs about the origins of life and the diversity of species. Some religious traditions reject evolutionary theory in favor of creationist explanations, while others seek to reconcile religious beliefs with scientific evidence. In addition, evolutionary theory continues to evolve and expand as new discoveries are made and new technologies are developed. Advances in fields such as genomics, proteomics, and computational biology are shedding light on previously unanswered questions about the mechanisms of evolution. Moreover, evolutionary theory has implications for our understanding of biodiversity loss, climate change, and ecosystem dynamics. By studying the evolutionary history of species and ecosystems, scientists can better predict how they will respond to environmental changes and develop strategies for their conservation and management. Furthermore, evolutionary theory emphasizes the interconnectedness of all life forms and the importance of preserving biodiversity for the health and stability of ecosystems. By understanding the processes of evolution, humans can better appreciate their place in the natural world and the responsibilities they have towards other species. In addition, evolutionary theory highlights the adaptive nature of life and the capacity of organisms to respond to changing environmental conditions. By studying the mechanisms of evolution, scientists can gain insights into how species might adapt to environmental challenges in the future. Moreover, evolutionary theory underscores the importance of scientific inquiry and evidence-based reasoning in understanding the natural world. By embracing the principles of evolution, individuals can gain a deeper appreciation for the diversity and complexity of life on Earth. Throughout this video, we've delved into the fascinating topic of whether the universe is infinite. We explored ancient philosophical views, early scientific theories, modern insights from astronomy, and contributions from Einstein and relativity. We also examined concepts from quantum mechanics, the scale of the observable universe, and the implications of cosmic expansion. Additionally, we discussed various hypotheses, including inflationary cosmology, multiverse theories, string theory, and the simulation hypothesis. Each section provided unique perspectives on the nature of the universe and its potential infinity. Considering the vastness of the cosmos and the complexity of theoretical frameworks, it's clear that the question of the universe's infinity remains open-ended. From ancient ponderings to cutting-edge scientific research, humanity has grappled with this fundamental mystery for millennia. While we've made tremendous progress in understanding the cosmos, there is still much we don't know. As we continue to explore and study the universe, it's essential to remain curious and open-minded. New discoveries and insights may challenge our existing paradigms and lead to profound revelations about the nature of reality. By staying engaged with the latest developments in cosmology and related fields, we can contribute to the ongoing pursuit of knowledge and understanding. If you enjoyed this video and found it informative, please consider liking and subscribing to our channel. Your support helps us create more content like this and share the wonders of science with a broader audience. Be sure to check out the rest of the videos on our channel for more fascinating explorations of the universe and beyond. Thank you for watching, and until next time, keep looking up. Evolutionary theory has long been a cornerstone of modern biology, providing a framework for understanding the diversity of life on Earth and the processes by which species change over time. However, this scientific concept has faced significant challenges from religious standpoints, particularly from creationist perspectives that interpret religious texts literally. One challenge to evolutionary theory comes from young Earth creationism, which asserts that the Earth is only a few thousand years old, and that all species were created in their present form by a divine creator. This viewpoint directly contradicts the vast body of scientific evidence supporting the theory of evolution, including fossil records, genetic evidence, and observations of natural selection in action. Another religious challenge to evolutionary theory comes from intelligent design, which posits that certain features of living organisms are best explained by an intelligent designer rather than natural processes. Proponents of intelligent design argue that the complexity of biological structures, such as the human eye or bacterial flagellum, cannot be adequately explained by evolutionary mechanisms alone. Some religious groups, such as certain branches of Christianity and Islam, accept the concept of evolution, but believe it was guided or directed by a divine creator. This view, known as theistic evolution or evolutionary creationism, seeks to reconcile religious beliefs with scientific understanding by interpreting the process of evolution as part of God's plan. Creationism has also been influential in shaping educational policies and public perceptions of evolution. In some regions, efforts to teach creationism or its disguised form, such as creation science or intelligent design, alongside or instead of evolutionary theory in public schools, have sparked legal battles and controversies. Despite the overwhelming scientific consensus supporting evolutionary theory, skepticism and opposition persist in many religious communities. Some religious leaders and organizations actively promote anti-evolutionary views, perpetuating misconceptions and undermining public acceptance of scientific evidence. The conflict between religious beliefs and evolutionary theory highlights broader tensions between science and religion in modern society. While some individuals and religious groups embrace scientific discoveries and seek to reconcile them with their faith, others reject scientific findings that challenge traditional religious teachings. Navigating these complex issues requires open dialogue, critical thinking, and respect for diverse perspectives. By fostering mutual understanding and encouraging informed discussions, we can bridge the gap between science and religion and promote a more harmonious relationship between the two domains. Ultimately, the challenges to evolutionary theory from religious standpoints reflect deeper questions about the nature of knowledge, truth, and the human experience. While science provides valuable insights into the natural world, religion offers unique perspectives on morality, purpose, and spirituality. Rather than viewing science and religion as inherently incompatible, many scholars advocate for a nuanced approach that recognizes the distinct but complementary roles of each domain. This perspective encourages dialogue and collaboration between scientists and religious thinkers, fostering mutual respect and appreciation for diverse worldviews. In conclusion, the challenges to evolutionary theory from religious standpoints highlight the ongoing tensions between scientific understanding and religious belief. While these challenges may persist, they also present opportunities for dialogue, reflection, and growth. By engaging with these issues thoughtfully and respectfully, we can deepen our understanding of both science and religion and foster greater harmony in society. Theistic evolution, also known as evolutionary creationism, is a theological perspective that seeks to reconcile religious beliefs with scientific understanding of evolution. It proposes that the process of evolution was guided or directed by a divine creator who imbued the natural world with purpose and meaning. Proponents of theistic evolution argue that God works through natural processes, including evolution, to bring about the diversity of life on Earth. They view scientific discoveries as revealing the intricacies of God's creation rather than as challenges to religious faith. Theistic evolution emphasizes the compatibility between scientific evidence for evolution and religious teachings, suggesting that the two can coexist harmoniously. This perspective allows individuals to embrace both their religious beliefs and an appreciation for the insights provided by modern science. While some religious traditions have been resistant to evolutionary theory, others have embraced theistic evolution as a way to bridge the gap between faith and reason. For example, many mainstream Christian denominations, such as Catholicism and certain Protestant denominations, endorse theistic evolution as compatible with their theological doctrines. Theistic evolution encourages believers to interpret religious texts in light of scientific discoveries and to approach questions of faith with humility and openness. It invites theologians and scientists to engage in dialogue and collaboration, enriching both fields of inquiry. Critics of theistic evolution argue that it compromises the integrity of religious teachings by accommodating scientific theories that challenge traditional interpretations of Scripture. They contend that accepting evolution undermines the concept of a literal Adam and Eve, as well as other foundational beliefs in some religious traditions. However, proponents of theistic evolution maintain that religious texts should be interpreted in their historical and cultural contexts, rather than as literal accounts of scientific events. They suggest that theological truths can be conveyed through metaphorical or allegorical interpretations of Scripture. Theistic evolution also raises questions about the nature of God's involvement in the natural world and the extent to which divine intervention is necessary to explain the complexities of life. Some theologians propose that God's creative activity is ongoing and dynamic, rather than confined to specific moments of intervention. From a scientific perspective, theistic evolution does not require invoking supernatural explanations for natural phenomena. Instead, it acknowledges the validity of evolutionary theory as a scientific framework for understanding the history and diversity of life on Earth. The compatibility between theistic evolution and scientific evidence for evolution reflects a broader trend toward integrating faith and reason in contemporary religious thought. It demonstrates that religious beliefs need not conflict with scientific understanding, and that both can contribute to a holistic worldview. By embracing theistic evolution, individuals can maintain their religious convictions while engaging with the insights of modern science. This approach fosters intellectual humility, curiosity, and a deeper appreciation for the complexities of the natural world. In conclusion, theistic evolution offers a compelling framework for reconciling religious beliefs with scientific evidence for evolution. It encourages dialogue, exploration, and mutual respect between religious and scientific communities, enriching our understanding of both faith and reason. Science education plays a crucial role in shaping our understanding of the natural world and fostering critical thinking skills. However, the intersection of science education and religious freedoms can be a complex and contentious issue, particularly when it comes to teaching topics such as evolution and the origins of life. In many countries, debates over science education often center on the inclusion of evolution in school curricula. Some religious groups advocate for the teaching of creationist or intelligent design perspectives alongside or instead of evolutionary theory, citing concerns about academic freedom and the rights of parents to educate their children according to their religious beliefs. These debates raise important questions about the role of religion in public education and the boundaries between science and faith. While science education aims to impart evidence-based knowledge and critical thinking skills, it must also respect the diverse religious beliefs of students and their families. In the United States, the issue of science education and religious freedoms has been the subject of numerous legal battles and legislative initiatives. Court cases such as the Scopes monkey trial and subsequent challenges to the teaching of evolution in public schools have shaped the legal landscape surrounding science education and the separation of church and state. The concept of academic freedom is often invoked in discussions about science education and religious freedoms. Advocates for the inclusion of creationist perspectives argue that students should be exposed to a range of viewpoints, including those that challenge mainstream scientific consensus. However, opponents of teaching creationism or intelligent design in public schools argue that these perspectives lack empirical support and are not scientifically valid. They contend that science education should be based on evidence-based principles and that religious beliefs should be taught in appropriate contexts, such as religious studies classes or within the home. Ensuring religious freedoms in science education requires careful consideration of the rights and responsibilities of educators, students, and parents. While educators have a duty to teach scientific concepts in accordance with established scientific principles, they must also be sensitive to the religious beliefs of their students and their families. One approach to addressing these challenges is to provide students with a well-rounded education that includes both scientific knowledge and an understanding of different religious perspectives. By promoting dialogue and mutual respect, schools can create inclusive learning environments where students feel comfortable exploring complex topics. At the same time, policymakers and educators must uphold the principles of academic freedom and religious neutrality in public schools. This requires navigating a delicate balance between promoting scientific literacy and respecting the rights of individuals to hold diverse religious beliefs. In conclusion, the intersection of science education and religious freedoms presents both challenges and opportunities for educators, policymakers, and communities. By fostering open dialogue, respecting diverse perspectives, and upholding the principles of academic freedom, we can promote a more inclusive and informed approach to science education that respects the rights and beliefs of all students and their families. Unsolved questions in astrophysics continue to intrigue scientists and fuel exploration into the mysteries of the universe. Among the most perplexing phenomena are dark matter, dark energy, and black holes, which challenge our understanding of the cosmos and the fundamental laws of physics. Dark matter, an invisible substance that comprises the majority of matter in the universe, remains undetectable by conventional means. Its existence is inferred from its gravitational effects on visible matter and the large-scale structure of the universe. However, the true nature of dark matter remains elusive, prompting ongoing research and speculation among astrophysicists. Dark energy, on the other hand, is believed to be the mysterious force driving the accelerated expansion of the universe. Unlike dark matter, which exerts gravitational attraction, dark energy is thought to produce a repulsive force that counteracts gravity on cosmological scales. Despite its profound implications for the fate of the universe, the origin and properties of dark energy remain poorly understood. Black holes are perhaps the most enigmatic objects in the universe, characterized by their intense gravitational pull from which no light can escape. These cosmic phenomena form when massive stars collapse under their own gravity, creating a singularity surrounded by an event horizon. While black holes are predicted by Einstein's theory of general relativity, many questions remain regarding their formation, behavior, and role in shaping the cosmos. The study of dark matter, dark energy, and black holes represent some of the most active areas of research in astrophysics. Scientists employ a variety of observational and theoretical techniques, including astronomical surveys, computer simulations, and gravitational wave detections, to probe these cosmic mysteries. Understanding the nature of dark matter is essential for deciphering the underlying structure and evolution of the universe. Current theories posit that dark matter may consist of exotic particles that interact weakly with ordinary matter, but direct detection efforts have thus far yielded inconclusive results. Similarly, unraveling the properties of dark energy is crucial for determining the ultimate fate of the universe. While the leading cosmological model, known as the Lambda Cold Dark Matter (LCDM) model, incorporates dark energy as a key component, alternative theories such as modified gravity and dynamical dark energy propose alternative explanations for the observed cosmic acceleration. Black holes, with their extreme gravitational fields and mysterious interiors, offer unique insights into the nature of space-time and the limits of our current understanding of physics. Recent advancements in observational techniques, such as the Event Horizon Telescope's imaging of the shadow of a black hole, have provided unprecedented glimpses into these cosmic behemoths. Despite these advances, many questions about black holes remain unanswered, including the nature of the singularity at their centers and the mechanisms governing their growth and evolution. Ongoing research efforts, including gravitational wave astronomy and numerical simulations, aim to shed light on these elusive objects. In summary, dark matter, dark energy, and black holes represent some of the most compelling mysteries in astrophysics. By probing these cosmic phenomena, scientists hope to unlock the secrets of the universe and deepen our understanding of its origins, evolution, and ultimate fate. The human quest for transcendence and meaning has been a central theme throughout history, shaping cultures, religions, and philosophies around the world. From ancient civilizations to modern societies, individuals have sought to understand their place in the universe and the purpose of their existence. Religious traditions offer answers to questions of meaning and transcendence, providing narratives of creation, morality, and the afterlife. Concepts such as God, soul, and divine purpose serve as pillars of belief systems that offer solace, guidance, and hope to millions of adherents worldwide. Philosophical inquiries into transcendence and meaning explore fundamental questions about the nature of reality, consciousness, and existence. From Plato and Aristotle to Kant and Nietzsche, philosophers have grappled with the mysteries of the human condition, seeking to uncover truths that transcend empirical observation. In the modern era, scientific advancements have transformed our understanding of the universe, challenging traditional religious and philosophical frameworks. The rise of secularism and skepticism has prompted many to question the validity of religious dogma and seek alternative sources of meaning and fulfillment. Yet, even as science offers new insights into the workings of the cosmos, it cannot fully address the existential questions that have preoccupied humanity for millennia. The search for transcendence and meaning remains a deeply personal and subjective endeavor, shaped by individual beliefs, experiences, and cultural contexts. Literature, art, and music provide avenues for exploring themes of transcendence and meaning, offering glimpses into the human spirit and its yearning for connection with something greater than itself. From ancient epics to contemporary novels, creative works reflect the universal quest for understanding and enlightenment. In the face of existential uncertainty, some turn to spirituality and mindfulness practices as a means of cultivating inner peace and transcending the limitations of the ego. Meditation, prayer, and contemplative practices offer paths to experiencing moments of transcendence and connection with the divine. Others find meaning through acts of service, altruism, and community engagement, recognizing the intrinsic value of human relationships and the importance of contributing to the well-being of others. By fostering empathy, compassion, and solidarity, individuals can find purpose and fulfillment in serving a greater good. The search for transcendence and meaning is not limited to any particular culture, religion, or worldview. It is a fundamental aspect of the human experience, rooted in our innate curiosity and desire to make sense of the world around us. Ultimately, the quest for transcendence and meaning is a deeply personal and individual journey, shaped by a multitude of factors including upbringing, culture, personal beliefs, and life experiences. While science may offer insights into the workings of the universe, it cannot provide definitive answers to existential questions about the purpose and meaning of life. In conclusion, the human quest for transcendence and meaning is a timeless and universal pursuit that spans cultures, religions, and philosophical traditions. Whether through religious faith, philosophical inquiry, artistic expression, or personal introspection, individuals seek to understand their place in the cosmos and find purpose and fulfillment in the face of life's uncertainties. Religious symbolism in cosmic phenomena has played a significant role in shaping human beliefs, rituals, and cultural practices throughout history. From the worship of celestial bodies in ancient civilizations to the incorporation of cosmic imagery in religious texts and iconography. The heavens have long been viewed as a source of divine inspiration and spiritual guidance. Many cultures have revered the sun, moon, and stars as gods or divine beings, attributing supernatural powers and significance to these celestial bodies. Sun worship, in particular, has been prevalent in numerous ancient civilizations, symbolizing life, renewal, and divine authority. The moon, with its cycles of waxing and waning, has also been associated with fertility, transformation, and the cycles of life and death. In many religious traditions, lunar phases are observed as auspicious times for rituals, ceremonies, and spiritual practices. Stars, with their twinkling lights and seemingly infinite expanse, have inspired awe and wonder in people across cultures and civilizations. In many mythologies and religious cosmologies, stars are depicted as celestial beings, guiding lights or symbols of divine presence and wisdom. Beyond individual celestial bodies, cosmic phenomena such as eclipses, comets, and meteor showers have also been imbued with religious significance. Eclipses, in particular, have often been interpreted as omens or portents of divine intervention, prompting rituals and ceremonies to appease the gods or ward off perceived threats. In addition to celestial bodies, cosmic events such as the creation of the universe, the formation of galaxies, and the birth and death of stars have been rich sources of religious symbolism and metaphor. Creation myths from diverse cultures often depict the universe as emerging from a primordial chaos or being shaped by divine forces. The concept of heaven, a realm beyond the earthly plane where gods, angels, and righteous souls reside, is a central tenet of many religious traditions. Descriptions of heaven often draw on cosmic imagery, portraying it as a celestial paradise adorned with radiant light, celestial gardens, and celestial beings. Similarly, the notion of hell, a realm of punishment and suffering, is often depicted in religious texts and imagery using cosmic symbolism, such as fire, darkness, and eternal damnation. The cosmic imagery associated with heaven and hell serves to reinforce moral teachings and concepts of divine justice. In religious art and architecture, cosmic symbolism is often employed to convey spiritual truths and inspire awe and reverence. Depictions of celestial bodies, cosmic events, and heavenly realms adorn sacred spaces such as temples, churches, mosques, and synagogues, serving as reminders of the divine presence and the transcendent nature of reality. The use of cosmic symbolism in religious rituals and ceremonies serves to connect individuals to the divine and to each other, fostering a sense of unity and belonging within religious communities. Rituals such as prayers, chants, and meditations often invoke cosmic imagery to evoke a sense of awe, wonder, and reverence for the divine. The exploration of cosmic symbolism in religious texts, rituals, and art offers insights into the human quest for meaning and transcendence. By drawing on the vastness and beauty of the cosmos, religious traditions seek to inspire awe, cultivate reverence, and awaken spiritual awareness in their followers. In summary, religious symbolism in cosmic phenomena reflects humanity's profound connection to the cosmos and its enduring quest for spiritual meaning and transcendence. From ancient sun worship to modern interpretations of heaven and hell, cosmic imagery continues to inspire awe, wonder, and reverence in religious traditions around the world. Mystical experiences and cosmic consciousness have been explored by mystics, philosophers, and spiritual seekers throughout history as a means of transcending the limitations of the ego and accessing higher states of awareness. These experiences often involve a profound sense of unity, interconnectedness, and oneness with the cosmos, leading to feelings of awe, bliss, and inner peace. Mystical experiences can occur spontaneously or be induced through various practices such as meditation, prayer, chanting, and psychedelic substances. Regardless of the method, the underlying aim is to quiet the mind, dissolve the ego, and open oneself to the direct experience of the divine or the cosmic. Cosmic consciousness refers to a state of awareness in which one perceives the interconnectedness of all things and experiences a deep sense of unity with the cosmos. This expanded awareness can lead to profound insights into the nature of reality, the self, and the universe, transcending ordinary perceptions and conceptual frameworks. Many religious and spiritual traditions regard mystical experiences as glimpses of ultimate reality or encounters with the divine. Mystics often describe their experiences using metaphorical language, drawing on cosmic imagery to convey the ineffable nature of their encounters. The study of mystical experiences and cosmic consciousness has gained interest in the fields of psychology, neuroscience, and consciousness studies. Researchers seek to understand the underlying mechanisms of these experiences and their potential therapeutic and transformative effects on individuals. Neuroscientific studies have shown that mystical experiences can be associated with changes in brain activity, particularly in regions involved in self-awareness, emotion regulation, and the processing of sensory information. These findings suggest that mystical experiences may have neurobiological correlates that contribute to their subjective effects. Psychological theories of mystical experiences propose that they arise from alterations in consciousness that disrupt ordinary modes of perception and cognition. These altered states of consciousness may be induced by factors such as meditation, prayer, sensory deprivation, or psychedelic substances. While mystical experiences are often associated with religious or spiritual practices, they can also occur spontaneously in individuals who have not actively sought them. Such experiences may be triggered by intense emotions, aesthetic experiences, or moments of existential crisis. The interpretation of mystical experiences varies across cultures and religious traditions, reflecting different cosmological beliefs, metaphysical frameworks, and spiritual practices. While some cultures regard mystical experiences as sacred and transformative, others may view them with skepticism or fear. Despite cultural differences in interpretation, mystical experiences share common themes of unity, interconnectedness, and transcendence. They challenge conventional notions of reality and invite individuals to explore the depths of their own consciousness and the mysteries of existence. The integration of mystical experiences into everyday life can be challenging, as they often involve radical shifts in perception and identity. Many mystics undergo a process of spiritual integration, seeking guidance from spiritual teachers, texts, and communities to make sense of their experiences and integrate them into their lives. In contemporary society, interest in mystical experiences and cosmic consciousness is growing, fueled by advances in science, technology, and spirituality. Many individuals seek to cultivate states of expanded awareness as a means of finding meaning, purpose, and fulfillment in an increasingly complex world. The exploration of mystical experiences and cosmic consciousness offers insights into the nature of consciousness, the mind-body relationship, and the potential for human transformation. By investigating these phenomena, researchers and practitioners hope to unlock new avenues for personal growth, healing, and spiritual development. In summary, mystical experiences and cosmic consciousness provide a window into the deeper dimensions of human existence and the interconnectedness of all things. Whether through religious practices, spiritual disciplines, or spontaneous insights, individuals can tap into these profound states of awareness to explore the mysteries of the cosmos and the nature of the self. Integrating scientific wonder and spiritual awe involves recognizing the beauty, complexity, and interconnectedness of the natural world, while also exploring deeper existential questions about the nature of reality and our place within it. This integrative approach acknowledges the complementary perspectives of science and spirituality, recognizing that both offer valuable insights into the mysteries of existence. Scientific wonder arises from the process of inquiry, observation, and discovery, as scientists seek to understand the fundamental laws and mechanisms governing the universe. It involves marveling at the intricate patterns, structures, and processes found in nature, from the microscopic world of atoms and molecules to the vast expanses of galaxies and cosmic phenomena. Spiritual awe, on the other hand, emerges from a deep sense of reverence, gratitude, and interconnectedness with the cosmos. It involves recognizing the inherent sacredness and mystery of existence, transcending the limitations of the ego, and opening oneself to the wonder and beauty of the universe. Integrating scientific wonder and spiritual awe requires cultivating a mindset of openness, curiosity, and humility, recognizing that our understanding of the universe is always evolving and that there are limits to what we can know. It involves embracing the unknown and embracing the paradoxes and mysteries that lie at the heart of existence. This integrative approach encourages dialogue and collaboration between scientists, philosophers, theologians, and spiritual practitioners, recognizing that each discipline offers unique perspectives and methods for exploring the nature of reality. By bringing together diverse voices and perspectives, we can gain a more comprehensive understanding of the cosmos and our place within it. At the same time, integrating scientific wonder and spiritual awe involves recognizing the limitations of both science and spirituality, acknowledging that each has its own domain of inquiry and methods of investigation. While science excels at explaining the mechanisms and processes of the physical world, spirituality explores the deeper dimensions of consciousness, meaning, and purpose. By integrating scientific wonder and spiritual awe, we can cultivate a deeper appreciation for the interconnectedness of all things and the profound mystery of existence. This integrative approach invites us to explore the wonders of the universe with both the rigor of scientific inquiry and the reverence of spiritual contemplation. Ultimately, integrating scientific wonder and spiritual awe can enrich our lives, offering a sense of meaning, purpose, and interconnectedness in an increasingly fragmented and materialistic world. It encourages us to approach the mysteries of existence with humility, curiosity, and wonder, fostering a sense of awe and reverence for the beauty and complexity of the cosmos. In summary, integrating scientific wonder and spiritual awe involves embracing the complementary perspectives of science and spirituality, recognizing their unique contributions to our understanding of the universe. It encourages us to explore the wonders of the cosmos with both the intellect of the scientist and the intuition of the mystic, fostering a deeper appreciation for the interconnectedness of all things and the mystery of existence. As cosmic stewards, humanity bears the responsibility of caring for the earth and preserving the integrity of the natural world. This stewardship entails recognizing our interconnectedness with all living beings and the delicate balance of ecosystems upon which life depends. Humanity's role as cosmic stewards extends beyond the earth to the broader cosmos, as we seek to understand and protect the vast and interconnected web of life that spans the universe. This includes exploring ways to mitigate the impact of human activities on the environment and promoting sustainability and conservation efforts on a global scale. As cosmic stewards, humanity has the opportunity to contribute to the ongoing evolution and flourishing of life in the universe. This entails cultivating a sense of reverence, gratitude, and responsibility for the natural world, recognizing that our actions have profound consequences for the health and well-being of future generations. Humanity's role as cosmic stewards also involves fostering a deeper sense of connection and empathy with all living beings, recognizing the inherent value and dignity of each individual and species. This entails promoting justice, equity, and compassion in our interactions with the natural world and striving to create a more harmonious and sustainable relationship with the Earth and its inhabitants. As cosmic stewards, humanity faces the challenge of addressing pressing environmental issues such as climate change, deforestation, pollution, and loss of biodiversity. This requires collective action and collaboration on a global scale, as well as a willingness to make difficult choices and sacrifices for the greater good of the planet. Humanity's role as cosmic stewards also entails exploring innovative solutions and technologies to address environmental challenges and promote sustainable development. This includes investing in renewable energy sources, adopting eco-friendly practices, and implementing policies that prioritize the protection of the environment and the well-being of future generations. As cosmic stewards, humanity has a responsibility to educate and empower individuals and communities to take action to protect the environment and promote sustainability. This includes raising awareness about environmental issues, fostering a sense of environmental stewardship, and providing resources and support for grassroots initiatives and community-based conservation efforts. Humanity's role as cosmic stewards also involves advocating for policies and practices that prioritize environmental conservation and sustainability at the local, national, and international levels. This includes supporting legislation and initiatives that promote renewable energy, protect natural habitats, and mitigate the impacts of climate change. As cosmic stewards, humanity must also confront the ethical and moral dimensions of environmental stewardship, grappling with questions of justice, equity, and responsibility. This includes considering the needs and interests of marginalized communities, future generations, and non-human species in our decision-making processes. Humanity's role as cosmic stewards requires us to recognize the interconnectedness of all life and the interdependence of ecosystems across the planet. This entails adopting a holistic and integrated approach to environmental stewardship that considers the social, economic, and ecological dimensions of sustainability. As cosmic stewards, humanity must also acknowledge the limitations of our current understanding and the uncertainties inherent in complex ecological systems. This requires humility, curiosity, and a willingness to learn from both traditional ecological knowledge and cutting-edge scientific research. Humanity's role as cosmic stewards also involves fostering a sense of wonder, awe, and reverence for the natural world, recognizing the inherent value and beauty of the Earth and its inhabitants. This entails cultivating a deep sense of gratitude and appreciation for the gifts of life and the wonders of the cosmos. As cosmic stewards, humanity has the power to shape the future of life on Earth and beyond, for better or for worse. This entails embracing our responsibility with courage, compassion, and creativity, recognizing that the choices we make today will have far-reaching consequences for the future of life in the universe. Humanity's role as cosmic stewards is both a privilege and a profound responsibility, calling us to act with wisdom, integrity, and foresight in our interactions with the natural world. This entails embracing our interconnectedness with all living beings and working together to create a more just, sustainable, and flourishing world for present and future generations. Exploring the ethical dimensions of space exploration raises complex questions about our responsibilities as stewards of the cosmos. It challenges us to consider the potential impact of our activities beyond Earth's atmosphere and the implications for other celestial bodies and potential extraterrestrial life forms. Environmental ethics in space exploration involves balancing the pursuit of scientific knowledge and technological advancement with the need to preserve the integrity of celestial environments. It requires us to adopt a precautionary approach to minimize harm and mitigate the risks of contamination or disruption to extraterrestrial ecosystems. And as we venture further into space, we must grapple with questions of ownership, sovereignty, and the ethical use of resources on celestial bodies such as the Moon, Mars, and asteroids. This entails developing policies and guidelines that promote responsible and sustainable exploration and utilization of space resources. Environmental ethics in space exploration also raises questions about the long-term impact of human activities on the cosmos and the potential for unintended consequences. It requires us to consider the ethical implications of space debris, pollution, and other forms of environmental degradation in space. As we contemplate the colonization of other planets and the establishment of human settlements beyond Earth, we must confront ethical questions about our obligations to future generations and the preservation of biodiversity in space. This entails considering the ethical dimensions of terraforming, habitat modification, and the introduction of non-native species to extraterrestrial environments. Environmental ethics in space exploration also involves addressing the ethical implications of space tourism, commercial space activities, and the privatization of space resources. It requires us to consider the rights and interests of all stakeholders, including indigenous peoples, marginalized communities, and future generations. As we expand our presence in space, we must strive to uphold ethical principles such as respect for autonomy, justice, and sustainability. This entails promoting transparency, accountability, and democratic decision-making processes in space exploration and development. Environmental ethics in space exploration also requires us to confront the ethical dimensions of potential conflicts and competition over space resources, territories, and strategic interests. It calls for dialogue, cooperation, and diplomacy to ensure the peaceful and equitable exploration and utilization of space. As we contemplate the future of space exploration, we must consider the ethical implications of emerging technologies such as space mining, genetic engineering, and artificial intelligence. This entails examining the potential risks and benefits of these technologies and implementing safeguards to prevent misuse or abuse. Environmental ethics in space exploration also involves engaging with diverse perspectives and worldviews to ensure that our decisions and actions reflect a plurality of values and interests. It requires us to foster inclusive and participatory processes that empower all stakeholders to contribute to the governance of space activities. As we navigate the ethical complexities of space exploration, we must remain vigilant and proactive in addressing emerging challenges and opportunities. This entails ongoing dialogue, research, and reflection to develop ethical frameworks and guidelines that promote responsible and sustainable practices in space. Environmental ethics in space exploration also raises questions about our responsibilities to protect and preserve celestial bodies as part of our shared cosmic heritage. It requires us to recognize the intrinsic value and significance of these environments and to steward them with care and respect. As we venture into the unknown realms of space, we must embrace the ethical imperative to act as responsible custodians of the cosmos. This entails recognizing our interconnectedness with all living beings and the interconnected web of life that spans the universe. Environmental ethics in space exploration challenges us to transcend narrow self-interest and to consider the well-being of the entire cosmic community. It calls for a holistic and integrated approach to space exploration that balances scientific, ethical, and spiritual considerations. As we chart a course for the future of space exploration, we must uphold the highest ethical standards and values, guided by a deep sense of reverence, humility, and wonder for the vast and mysterious cosmos that surrounds us. Social justice in space exploration and colonization is a pressing issue that requires careful consideration and proactive action. It involves addressing systemic inequalities, historical injustices, and power imbalances that persist on Earth and may be perpetuated in space. As we embark on missions to explore and colonize other celestial bodies, we must ensure that the benefits and opportunities of space exploration are equitably distributed among all members of society. This entails promoting diversity, inclusion, and representation in the space industry, and ensuring that marginalized communities have a voice in decision-making processes. Social justice in space exploration also requires us to confront the legacy of colonialism and imperialism, which have historically exploited and marginalized indigenous peoples and communities. It calls for acknowledging and redressing past injustices and ensuring that indigenous rights and perspectives are respected in space activities. As we establish human settlements on other planets and celestial bodies, we must strive to create inclusive and just societies that uphold the principles of equality, dignity, and human rights. This entails designing governance structures, laws, and policies that promote social equity and address the needs of diverse populations. Social justice in space exploration also involves addressing economic disparities and ensuring that the benefits of space resources and opportunities are shared fairly among all members of society. This requires implementing measures to prevent the concentration of wealth and power in the hands of a few, and promoting equitable access to space-related education, training, and employment. As we contemplate the future of space colonization, we must consider the ethical implications of potential conflicts over territory, resources, and sovereignty. This entails promoting dialogue, cooperation, and peaceful resolution of disputes to ensure that space activities contribute to global peace and security. Social justice in space exploration also raises questions about the ethical use of artificial intelligence, robotics, and automation in space missions and colonization efforts. It requires us to address concerns about job displacement, labor rights, and the potential for discrimination and bias in AI systems. As we expand our presence in space, we must be mindful of the environmental impacts of space exploration and colonization on celestial bodies and extraterrestrial ecosystems. This entails adopting sustainable practices and minimizing our footprint to preserve the integrity and biodiversity of space environments. Social justice in space exploration also requires us to consider the needs and interests of future generations and to ensure intergenerational equity in our decision-making processes. This entails adopting a long-term perspective and implementing measures to protect the rights and well-being of future inhabitants of space colonies. As we venture further into space, we must be vigilant in addressing issues of social justice and equity to prevent the perpetuation of inequalities and injustices that have plagued human societies on Earth. This requires a proactive and inclusive approach that prioritizes the needs of the most vulnerable and marginalized populations. Social justice in space exploration also involves promoting education, awareness, and advocacy to empower communities and individuals to participate meaningfully in space activities and decision-making processes. It requires fostering a culture of inclusivity, solidarity, and mutual respect among all stakeholders in the space community. As we strive to build a more just and equitable future in space, we must draw inspiration from the principles of human rights, social justice, and planetary stewardship. This entails recognizing our shared humanity and collective responsibility to create a more equitable and sustainable future for all inhabitants of the cosmos. Social justice in space exploration is not just a moral imperative, but also a pragmatic necessity for the success and sustainability of space missions and colonization efforts. It requires us to address underlying social, economic, and political inequalities that may hinder progress and exacerbate conflicts in space. As we embark on this unprecedented journey into the cosmos, let us not forget the importance of social justice and equity in shaping the future of humanity's cosmic endeavors. Together, we can strive to build a more inclusive, equitable, and just future in space for generations to come. Bioethical considerations in interstellar travel and terraforming are paramount as we contemplate the possibility of establishing human settlements on other planets and celestial bodies. These considerations encompass a wide range of ethical issues related to the impact of space exploration and colonization on extraterrestrial environments, indigenous life forms, and potential human inhabitants. As we venture beyond Earth, we must grapple with questions about the moral implications of altering and potentially contaminating other worlds through terraforming and planetary engineering. This entails considering the rights of indigenous life forms and ecosystems to exist free from human interference and exploitation. Bioethical considerations also extend to the health and well-being of human explorers and settlers in space. This includes addressing concerns about radiation exposure, microgravity effects, psychological stress, and the long-term consequences of living in enclosed habitats or terraformed environments. As we develop technologies for interstellar travel and colonization, we must ensure that they adhere to ethical principles and standards that prioritize the safety, autonomy, and dignity of all sentient beings involved. This requires robust regulatory frameworks and oversight mechanisms to prevent harm and uphold ethical standards. Bioethical considerations in interstellar travel also raise questions about the ethical use of genetic engineering, biotechnology, and synthetic biology to adapt humans to alien environments or enhance their capabilities for space exploration. This entails weighing the potential benefits of genetic modification against the risks of unintended consequences and ethical concerns about genetic enhancement. As we contemplate the possibility of terraforming other planets to make them habitable for humans, we must consider the ethical implications of transforming alien ecosystems and landscapes. This includes assessing the ecological impact of introducing Earth organisms and altering planetary climates, geology, and atmosphere. Bioethical considerations in interstellar travel and terraforming also intersect with broader ethical debates about environmental conservation, sustainability, and the rights of future generations. This entails adopting a precautionary approach and considering the long-term consequences of our actions on planetary and cosmic scales. As we expand our presence in space, we must be mindful of our ethical responsibilities as stewards of the cosmos and guardians of life. This requires humility, empathy, and a deep appreciation for the interconnectedness of all living beings and ecosystems. Bioethical considerations in interstellar travel and terraforming also raise questions about cultural diversity, indigenous rights, and the preservation of cultural heritage in space. This entails respecting the traditions, beliefs, and values of indigenous peoples, and ensuring that their voices are heard in decisions affecting their ancestral lands and territories. As we contemplate the future of interstellar travel and colonization, we must engage in dialogue and collaboration with ethicists, scientists, policymakers, indigenous communities, and other stakeholders to develop ethical guidelines and principles that promote responsible and sustainable space exploration. Bioethical considerations in interstellar travel and terraforming also require us to confront ethical dilemmas and trade-offs inherent in our quest for cosmic exploration and expansion. This entails balancing the pursuit of scientific knowledge and technological progress with ethical considerations about the sanctity of life and the preservation of biodiversity. As we navigate the complexities of interstellar travel and terraforming, we must strive to uphold ethical values such as respect for autonomy, justice, beneficence, and non-maleficence. This requires ethical reflection, critical thinking, and a commitment to ethical decision-making in the face of uncertainty and ambiguity. Bioethical considerations in interstellar travel and terraforming also raise questions about the ethical responsibilities of spacefaring nations, corporations, and organizations to adhere to ethical standards and norms in their activities beyond Earth. This entails promoting transparency, accountability, and democratic governance in space exploration and colonization efforts. As we embark on this unprecedented journey into the cosmos, let us not forget the importance of bioethical considerations in shaping the future of humanity's interstellar endeavors. Together, we can strive to ensure that our exploration and colonization of space are guided by ethical principles that uphold the dignity, rights, and well-being of all sentient beings. Moral obligations in utilizing astrophysical resources are complex and multifaceted, requiring careful consideration of ethical principles and values. As humanity explores and exploits the resources of the cosmos, we must grapple with questions about the ethical implications of our actions on a cosmic scale. Utilizing astrophysical resources such as asteroids, comets, and other celestial bodies raises ethical questions about ownership, stewardship, and the equitable distribution of resources. This entails addressing issues of property rights, sovereignty, and the common heritage of humankind in outer space. Moral obligations in utilizing astrophysical resources also encompass concerns about environmental impact, sustainability, and the preservation of cosmic ecosystems. This includes assessing the long-term consequences of resource extraction, habitat disruption, and pollution in space. As we develop technologies for mining asteroids, harvesting solar energy, and exploiting other astrophysical resources, we must consider the ethical implications of our actions for future generations and the wider universe. This entails adopting a holistic approach that takes into account the interconnectedness of all cosmic phenomena. Moral obligations in utilizing astrophysical resources also raise questions about social justice, equity, and the fair distribution of benefits and burdens. This includes ensuring that the benefits of space exploration and resource utilization are shared equitably among all members of society, regardless of nationality, socio-economic status, or other factors. As we venture further into space and encounter potentially habitable exoplanets, we must confront ethical dilemmas about colonization, terraforming, and the rights of indigenous life forms. This entails respecting the autonomy, dignity, and intrinsic value of all sentient beings and ecosystems. Moral obligations in utilizing astrophysical resources also extend to considerations of cultural diversity, heritage preservation, and the protection of sacred sites in space. This includes recognizing and respecting the cultural significance of celestial objects and phenomena to different communities and traditions. As we expand our presence in space and establish human settlements on other worlds, we must uphold ethical principles such as respect for human rights, democracy, and the rule of law. This requires promoting inclusive and participatory decision-making processes that involve all stakeholders in space exploration and colonization efforts. Moral obligations in utilizing astrophysical resources also entail promoting peace, cooperation, and international collaboration in space activities. This includes fostering dialogue, diplomacy, and conflict resolution mechanisms to prevent the weaponization of space and mitigate potential conflicts over resource access and control. As we navigate the ethical complexities of utilizing astrophysical resources, we must strive to develop ethical frameworks and guidelines that promote responsible and sustainable space exploration and exploitation. This requires engaging in interdisciplinary dialogue and collaboration to address ethical issues from diverse perspectives. Moral obligations in utilizing astrophysical resources also raise questions about intergenerational equity, planetary stewardship, and the long-term survival of humanity. This entails considering the ethical implications of our actions for future generations and the resilience of cosmic ecosystems. As we contemplate the ethical dimensions of utilizing astrophysical resources, we must recognize the interconnectedness of all life and the interdependence of Earth and the cosmos. This requires a shift towards a more holistic and inclusive approach to space exploration and resource utilization. Moral obligations in utilizing astrophysical resources also call for reflection on our values, priorities, and aspirations as a species. This includes considering the ethical significance of our cosmic journey and the impact of our actions on the future evolution of life in the universe. As we embark on this unprecedented adventure into the cosmos, let us not forget the moral imperatives that guide our exploration and exploitation of astrophysical resources. Together, we can strive to ensure that our cosmic endeavors are guided by ethical principles that uphold the dignity, rights, and well-being of all sentient beings, now and for generations to come. Throughout this video, we've delved into the intricate and fascinating interplay between science and philosophy, exploring a wide range of topics from ancient philosophical views to modern insights from astronomy. We've examined the contributions of notable figures like Einstein and explored complex theories such as quantum mechanics and string theory. From the size and scale of the observable universe to the limits of human understanding, we've journeyed through the depths of cosmic inquiry. Our exploration has not only deepened our understanding of the universe, but also sparked profound questions about our place within it. We've pondered the significance of concepts like infinity, transcendence, and cosmic consciousness, contemplating the mysteries that lie beyond the reaches of our comprehension. Along the way, we've encountered challenges, controversies, and ethical dilemmas that remind us of the complexities inherent in our quest for knowledge. As we conclude this video, I invite you to reflect on the insights gained and the questions raised. If you've enjoyed this exploration of the cosmos and the human condition, I encourage you to like this video and subscribe to our channel for more thought-provoking content. By doing so, you'll join a community of curious minds, eager to explore the wonders of the universe together. Don't forget to check out the rest of the videos on our channel, where you'll find a wealth of content covering a diverse range of topics in science, philosophy, and beyond. Whether you're passionate about astrophysics, intrigued by existential questions, or simply seeking to expand your horizons, there's something here for everyone. Thank you for joining us on this journey of discovery. Together, let's continue to explore the mysteries of the cosmos and unlock the secrets of existence. Remember to like, subscribe, and share with fellow seekers of knowledge. Until next time, keep looking up at the stars and pondering the wonders of the universe.